You can go, but people, I mean, I want to.
Great, and we're live from the MIT Media Lab. Hi, I'm Dazza Greenwood, and this is GDPR Hack Day. And we're about to start a joint panel with our friend and colleague Mark Lazar in London on the algorithmic sections for GDPR. And so since most of the panelists are in London, I'm going to hand it over to Mark to get the festivities started. So Mark, it's all yours.
Thank you, Dan. We're all really happy. Okay. Yes. We're just tuning in the. Can you guys hear me now? Is that good? No. Okay.
No.
No. So I have to be over here. Can you hear now?
Yes. Yes.
All right.
You won't get the actual view through their speech.
All right. We're talking about muting and unmuting just to get these speakers going. But hi everyone. So we've been having a really good day with everybody presenting, and I'm just going to hand it over to Nicola, who's actually hosting this session, and then we're going to wrap up with some discussion and questions from both people, both places. So here you go, Nicola.
Yeah. Okay. Hi everyone from MIT. So it's been a long day of discussion, and we have talked basically so far about two issues, as you might have seen from the program. One panel was more about standards, the need for standards in this field to facilitate, data exchange in line with privacy. And the second panel was more focusing on benefits, opportunities, and challenges in relation to data portability. So we have been focusing not only on the portability right that is given by the GDPR, but going a little bit broader. And one of the issues that came out in the last discussion was specifically how the data portability and the facilitation of exchange and accessing to data is in tension potentially with decisions that can be made through those data through algorithms that can have adverse effects for individuals. So when you have some kind of trade-off, the example of an insurance was made where you are required to give some data in order to have a discount, and with those data they're going to make a much better profile of you. So that's what we left for this panel. We said, yeah, in this panel we are going to investigate ways in which we can provide some more transparency and accountability with regard to those kind of decisions. So just by way of introducing the GDPR, we have a few key provisions that increase the amount of agency that users have with regard to algorithmic processing. You might have heard about the debate on the right to explanation. So Article 22 of the GDPR requires that no decision shall be taken that has a significant effect on individuals, and it's based solely on automated processing, except for some specific circumstances. So this decision can be made only if they're based on explicit consent of a data subject or a contract with the data subject. And in any case, there should be some minimum safeguards, which are the right to obtain human intervention and the right to contest the decision. So in this panel, we want to explore some potential ways that these services that are going to spring up with the GDPR can facilitate that kind of intervention and explanation for users to understand how the algorithmic choices are made. So we have a fantastic lineup. I'm going to start throwing the ball back to you at MIT because I think Thomas' presentation is going to connect very well with the previous panel, since we are talking indeed about PIM services, and your presentation is really about that. It's about personal intermediary, and it's a term that I'm very much endorse. So just by way of introduction, Thomas Aggiorno works at MIT for the OPAL project. I guess you can tell us a little bit more about this project as you introduce yourself, maybe more accurately. Yeah, after that you are going to make your intervention, we are going to throw it for some possible burning questions, but we are going to keep the discussion with more flow towards the end. So after everyone has made the presentation, and we'll reserve some time from questions from MIT. So thanks for that, and I'll leave it to you, Tom.
Let me just one take. Just so you guys know, Daza had this project with MIT called Clear Button a long time ago, which is the concept that someone could press a button and get ask everyone for their data, and especially those organizations that don't have a relationship with. And that was like a long time ago, and now we are here and we're actually talking. So really, partly if you have detail about what happens when you press the button. What is the actual definition of the terms of the thing, not the concepts or the law so much, but the operational, how does it work is very important. So thanks.
Yeah, over to you.
Okay, great. Can you flip the slide to slide number 2, Mark or Nicolo?
Yes. Wait a second. Now, we do have the slides available, but we we need to put the projector back on.
He put the whole thing on together the last second on their side.
Are we good?
No, not yet, but you can start talking and hopefully we'll speed up with it.
So the vision of Opal came through research here at MIT, which is focused on how you can combine data from different data domains and obtain interesting insights. So one of the interesting papers that I encourage you to look up is called Money Walks. And it is a research that combined credit card data together with movement data, GPS data, so basically telco data and credit card data. And one of the goals of that research was to provide increased accuracy in predicting credit card churn. Churn in this case means that somebody drops a card brand for a different brand. You go from Visa to MasterCard. You go from a Bank of America Visa to a Capital One Visa, that kind of thing. And this question is actually preeminent for the folks in MasterCard. MasterCard's got an entire group just working on data analytics. And what this research showed was that if you are able to combine this data together, you get an increase of up to 30% in accuracy in predicting the churn rate for a group of people or persons within the next 6 months, right? So this is something unheard of in the card payments industry, right? That's 30 years worth of ideas. Now, the challenge there is that you need to get access to this diverse data. And so slide number 2 is our vision slide. And so it basically, could we do privacy-preserving data sharing, or more correctly, privacy-preserving insights sharing across different data domains, telecoms data, finance data, social data, health data, you name it. And within each of these, there's different subsegments of the market. Next slide, please.
Yes. Got it.
Yes, you have the slides. We can put them here. So the next slide is personal data is a new asset class. So I will do this for the folks. I know my slides. I kind of made them. So if you are interested in some bedtime reading, I would encourage you to look at the blue or the purple report here. It's a 2011 report from the World Economic Forum, the big data group there. And basically, I don't want to say it's a sequence of complaints, but it is a sequence of complaints about how badly personal data is treated, infrastructure is a mess, we don't know where. It's like, okay, you don't get depressed, I hope, reading that. But the key thing is that this group is chaired by Sandy Penland, who's our director here. And the other key point is that much of the readership of this document was in fact the European regulators who proceeded to draft up GDPR. So there is influence there. I also encourage you to read the paper on the right-hand side, which is a Scientific American paper from 3 or 4 years ago, Saving Big Data from Itself, which is, this is, don't forget, this is in the big boom of big data and analytics, and here's a paper saying, whoa, and one of the themes there is surveillance, right? So this is one of the, and I think when I could be mistaken that when we had the Snowden inquiry, this was probably the only paper that was cited by the committee saying like, okay, this is there's some interesting threads in there. I'll let you guys read that. Moving on to the next slide. So open algorithms, OPAL stands for open algorithms. Yes, we're awful at marketing and choosing brands. We're too geeky to be choosing brands. So there's some very simple principles, simple in words, but could have dramatic implications on how people do analytics. The first is move the algorithm to the data. So this means that stop doing all this data copying and data selling and instead send the algorithm to the data. Now, this is classic client-server architecture from the 80s when people had dumb terminals and all the processing power is on that side, right, the server side. This is like that. The idea here is that in order to remain consistent with the notion of keeping data where it is, you need to just move the algorithm there, which is in contrast to what people do today for the big analytics platforms like Hadoop or Spark. The assumption is you've got all these petabytes of data at your disposal, and your next problem is how to clean it, how you upload it, how you do all these clustering, which are all fun and great, but it works on the assumption that you have access to the data, which is not always the case. Secondly, which is probably important for the GDPR, in particular Article 22, is the idea of vetted algorithms only. So the term vetting here is kind of hand-wavy, let's just say, but the idea is that when you want to pair an algorithm or a set of algorithm with data sets, you need to understand bias and a built-in unfairness. It's not because it's bad, it's just built in. Because when people collect data, it's not necessarily fair. In fact, there's a famous paper I also encourage to read. It reads, raw data is oxymoron. The original testing is raw data. Every data is biased. This is the way you collected it, right? Maybe IoT device data is kind of neutral. So you need to get the algorithm vetted by an expert, somebody who's in the field. Now, for those who are in the AI and machine learning field, you will know that the topic of fairness in machine learning is a huge, huge topic, multiple conferences, and it is quite a difficult topic. But the idea also is that a consumer needs to know what the algorithm does. There's no point giving the consumer a Python code that implements it. No, you have to explain it, and your explanation has to have some kind of a legal, bearing. You have to have responsibility to when you explain this to the consumer. The third is data always encrypted. So next generation cryptographic solutions such as homomorphic encryption and multi-party computation allow you to do encryption on encrypted data without decrypting. So can you compute on encrypted data?
Is that homomorphic?
That's homomorphic encryption. There's two branches in the field, homomorphic encryption and multi-party computation. And this is relevant for organizations that hold your data. So let's say Equifax had a solution like this. If somebody broke into Equifax, they'd be stealing encrypted data, right? They wouldn't be able to do anything with it. Decentralized and distributed repositories. We all have blockchain, both the real and the metaphor, because everywhere I go, 90% of what people say about blockchain is really the blockchain metaphor. Decentralized. So if we are going to keep data where it is and not move it, you end up with a distributed data architecture. So how do you address these challenges, going forward? If you wanted to know more about this, I encourage you to look at the July European presidency, presentation. So the keynote is by Professor Sandy Pentland. He has a very high-level presentation. If you just Google EU presidency keynote July 2017, you'll see that. Moving on to the next slide, the MIT Opal slide, please, Mark and Nicolo.
Yes, yes. Yeah.
So this is a very high-level view of Opal. It has query processing capabilities, machine learning capabilities, privacy protection, nice broad term, data, of course, algorithms, and consent management. So this is probably what would be relevant for this audience here today. And when we say consent management, of course, we mean, you know, GDPR compliant consent, you know, management in the sense of obtaining consent, producing a consent receipt, and being able to track it. So we talk about using blockchains to track consent receipts and so on. Fine, that's easily doable. So the other thing that's important that sometimes people forget when they talk about data and algorithms is the provenance of the data. So the way the industry works today, at least in the US, there's a thriving aggregator market, which is companies that scour the internet, scrape stuff about people, and then resell it to people who are looking for data, marketing companies and so on. And number one, we don't know the provenance of that data. Number two, the accuracy is not so good. So if you want to run a business, you want to run the next shoe company, Zappos, whatever, and you're looking for customers, you'll be paying maybe $500, $600 per lead, you know, to the aggregator, and the success rate is 5%, 10% only. So the negative is like big chunk, right? This just illustrates how the data, you know, is just poor quality. Next slide, please, which is this personal intermediary.
Okay.
So Thomas, which
Number 6.
Okay, good. Yeah, you were right.
Yeah, number 6. So since we're in the panel, I don't want to take up all the time. So the idea here is that could you create a instance of the Opal framework for personal data stores? So I would maintain a data store, but more importantly, I would have an online agent, and we'll just leave it at that because you can have virtual machines, all that stuff up there. It doesn't matter. It's an agent that is essentially my proxy, and it would interact with social platforms on my behalf. But more importantly, it would collect all the data that comes through as if I was browsing on Facebook. So instead of Facebook, me with my Facebook app, it's a client talking to the Facebook server directly, and all the data that, including all the junk, advertising, everything gets collected, put into my data store. The point being is that these data stores become important tools to do analytics, because you don't know what, you know, individually it may be meaningless, but you guys remember the case when Facebook announced last year, 2 years ago, that they did an experiment with 100 users where they injected certain feeds and were measuring people's reactions over a period of 2 months or 3 months, right? And so they announced it, and people like, this is before Analytica, by the way. I don't know if people don't read it. Just like, what? There's no like, you know. And the only reason is 100 people, and everybody thought, well, that's harmless, right? But what if you could reverse it and say, well, everybody in this room has a personal data store, all the complete feeds, and what if you could run your analytics on this, right? And so it's AI data driven. And what if you could put this on peer-to-peer nodes encrypted, right? So that means it's a permanent storage of history of your life. Next slide, please, the one with the diagram. So this shows a very high-level, fancy diagram of my Opal and blockchains and so on. We think that the idea that every individual will be having their own server at home is not going to work. So you're going to be hosting this somewhere. You're going to get this as a service. So the important point there is that the service operator needs to enter into a contractual agreement with you, the individual, as to rules like GDPR compliance. They're not allowed to copy your data. They're not allowed to read your data, and so on and so on. They have a fiduciary obligation to you regarding your data. So people, this term is coming into vogue now. People are talking about personal data banks. The Japanese government are talking about personal information banks. My bank has a fiduciary obligation to me, with regards to financial matters. So why can't we have something like that? And I think Daz has talked about the idea of credit unions to organize this a while back. So the credit union in the US is an interesting legal construct that might be interesting. Finally, last slide, the two books. Again, if you are looking for sleeping material and there's nothing on TV and Netflix and Amazon Prime is just not cutting it. Take a look at these two books. We'll be revising it pretty soon, but it's got a good summary of the research that we do here at MIT. That's the end of the slide. Oh, last slide, URLs if you want to look at some more, trust.mit.edu and connection.mit.edu.
All right. Thomas, amazing.
Any questions? Okay.
Any burning question now?
Just first, hello to everybody who's tuning in over the internet. We know that you are live streaming now, and I'm not sure, Daz, if you can see how many people, but we're getting lots of emails, so everybody's liking your presentation. If nobody has, I have a clarifying question, which is about the AI and data-driven nature of this service. So do you mean that basically it's going to learn user preferences and act on behalf of the user? For example, by recommending which websites to go to, which kind of services are catered to him, or would it act only under the specific instruction of the user, or something in between?
So the AI and the machine learning is owned by the user, right? So the idea is to level the playing field. So in the sense, well, I could have an AI engine that essentially warns me of certain anomalous behavior on my Facebook stream or on my Twitter stream, right? A group of people could share temporary access to their PDS and run a collective AI to decide, has Facebook been gaming us? Because that's what they do. That's what Analytica has been doing, right? Is there a covert channel happening here where we don't even realize we're being played, right? So can we do that, right? So, hey, Sal.
Hey, Thomas. So you, can you hear me okay? Yeah, I guess you have to come up. Yeah. So it sounds like what you're talking about is really maybe starting with an alarm monitor before you get to delegated authorization from an AI perspective, right? I mean,
yes.
if something, so if you could have an AI as watchdog, I guess would be as opposed to an AI. In broader terms, which makes a lot of sense, I guess. Right? But the term AI there, the mind wanders, right?
Okay, yes, okay, good. Thank you, Sal.
Yeah. Another just tiny question. Have you thought about the legal issues with scraping? Because I think what you're doing there is getting a lot of information from Facebook, not probably in accordance with their terms of service. Is that a potential legal issue?
That's a good one. Maybe we should go to court.
Okay. No, there was actually a recent case.
You need to test this out. I mean, you need to get this in court and see. I mean, the only way it seems nowadays to get any action is to drag Zuckerberg in front of the cameras. I mean, really.
Although,
how else are you going to get action, right?
It doesn't go without saying that, my personal favorite article of the GDPR, Article 15, giving people a right to access their own personal data, would be the core authoritative source of data that people would be getting from Facebook and putting in their personal data store. And so that would hardly be a violation of law. That would be enforcement of law.
Right.
Yes. Also, there is a difference between requesting and self-enforcing, the law. But I am totally with you in spirit. I just see that Facebook will probably fight back, as you know.
Of course, yes.
Okay. So with that,
There are rumors, right, on Facebook's response to GDPR to just moving the servers, moving the data out of European servers and into elsewhere, right? So that
it's cheaper.
Do that. That's the whole.
In the worst case is that you could demand reciprocity from Facebook, right? So if they're going to start complaining about something, you could fine as long as you treat me the way you want me to treat you. And so maybe in some ways that might even be a thin wedge, right?
I mean, I think a good progress would be that if the events in Europe could force an open API for Facebook. Right?
Yeah.
So this publish API that so long as you sign on, you can get access to your own data through this API. So you can build your own apps, you can build your own tools, equals the playing field, right?
Yeah.
So levels playing field.
Great.
All right.
So I think more panelists coming from London, England.
Exactly. So thanks for the provoking presentation. Now we are gonna continue the conversation. Thomas, please stay there, and we would want a discussion at the end. So now the second speaker is Vaishak. Just a second. Do you have the slides up? They're there on the computer. So Vaishak Belle is an assistant professor and chancellor fellow at the School of Informatics in the University of Edinburgh, and an Alan Turing fellow. He has done a lot of work on artificial intelligence, published over 40 scientific articles, won prizes. So we are excited to have him here. He's going to talk about explanation as a service. All right. Oh, yeah. Just hi, guys. This is Vaishak. Yes. Okay. Oh, now, yeah, right. Okay, we're going to allow direct view of the speaker. Perfect. Okay. Okay, and you have to speak on the microphone as well.
Okay. Can I put that here, or?
Yeah, I think so.
Can you guys hear me?
Yeah.
Yes. Okay. Good. Oh, they don't have the slides.
I'm gonna send you guys the slides. Right
yeah. Go ahead and do that.
Yeah. That's
okay. So I want to thank Nicola for inviting me here. As Nicola mentioned, I work in the area of AI. I've been working on it for a couple of years. And this is sort of a high-level perspective. So let me say up front that it does not mention PIMs. What it does mention is the fact that, you know, the way AI is able to exploit data is very magical in some sense. And so what it tries to give you is a perspective on what does it mean to actually have explainability, and how potentially in your system, you know, again, it's sort of a high level, but based on technical considerations, what it would mean to offer explanations to your customer or user. Okay, so let me sort of start by, you know, basically mentioning what's going on with explainable AI. Why are we suddenly concerned about that now? Some key issues and some solutions, and finally conclude. All right, if you look at the current state of AI, right, it's quite likely that you'll see two extremes. On the one hand, you'll have tons of news articles talking about AI systems supposedly reaching near human abilities, but in carefully defined, circumscribed tasks, right? You're talking about poker, you're talking about, you know, Go, you're talking about chess, and so on and so forth. But, you know, if you put that aside, what you have to recognize is that practically every app you use on your phone is using some form of AI. Right, right from recommendations on IMDb, you know, what movie to watch next on Netflix. Your credit approval is essentially based on some kind of decision-making, automated decision-making. Recruitment, you know, who contacts you, who gets to see your profile on LinkedIn. You know, all of these decisions are based on AI. Of course, I'm not saying that you know, AI is in a sense not one thing, but a collection of different techniques, right? So it's not a surprise that everything gets clubbed as AI. But they are very different. So I say at a high level, I won't go into too much detail, but I'm just saying that there's a spectrum of techniques and the way it impacts you, right? So why do we care about explanation? So one of the interesting things about, at least if you look at the second part of the spectrum, is that AI systems sort of you know, deployed an application, a very complex pipeline. And it's near impossible to verify what's going on where, right? Sure enough, there is some amount of data collected. There's some kind of algorithm that works on this data, but it's in some part of this abstract pipeline that it's pretty hard to, you know, run an end-to-end verification. And the interesting thing is, of course, you know, in the more, you know, things like recommending movies and Amazon and so on, these decisions are based on millions of data points, right? Every interaction that the company has recorded is essentially contributing to the decision, and it's based on what is called as a feature space. What that means is that they look at all of these data points, they try to figure out what essentially is important for making a decision, and they construct this kind of feature space, and that's essentially what's driving the decision. So for instance, you know, things that you might buy on Amazon, what they're going to be interested in is, what did you buy in the past? Who are the people, what are the kinds of products you look at when you search for a certain product? All of these are essentially impacting the decision, right? So, you know, one of the naive perspectives you could take here is that, you know, so what? Why do we care, right? As long as it works, as long as it does the job for me. Actually, there are tons of reasons to be very doubtful of what's going on. This is sort of an example that's been coming up quite recently. So as you can see, that's a label of a panda, right? Good enough. Then there's the way, you know, as I mentioned, these artificial intelligence systems are based on this very complex feature space. And some of these features might be like regions of interest, you know, certain subcircles. For instance, obviously the distinguishing factor for a panda for us as human beings is the fact that they have these big black eyes, right? But you don't really know what's going on inside one of these machine learning systems. So you could have these very funny looking noise models that you add to this image, and suddenly it says it's something else, right? And this noise model is so abstract, and yet you know, you could get very high confidence that you know, the labeling is something very bizarre and strange. So you know, so think of this not just in the context of image recognition, but any kind of application that you might be using AI. If somebody is able to inject a small amount of noise and get the decision about you to be very different, it's something for you to worry about. Often what happens is that there's a huge mismatch in terms of what you expect to see and what you actually have. So as you know, every system, every startup, right, it's starting at some point. It starts off by 100 users, 200 users, scales up to 1 million users, right? And it's taking decisions incrementally, right? So you could imagine that it's taking a decision based on this black line, but the true distribution is missing these two important points at 50 and 80. Right. So again, this is a sort of a diagrammatic perspective trying to show that the decisions it takes could be based on something very different from the things it's collected so far. And this could potentially impact you in very adverse ways. Of course, there are the societal implications. There has been many studies to indicate that, you know, users are much more likely to trust the system when they have an explanation. And one of the interesting things that's coming out recently in machine learning is that what if this decision was based on historical data that happens to be biased, right? For instance, we know that there's a lot of historical data that shows that there was negative biases against women. Imagine this data is fed into one of these systems, right? You don't specifically, you know, bias the system, but because it uses this data, it's going to automatically infer the, you know, inherit these biases. There are, of course, the legal implications. GDPR, I think, is just one instance. And I'm glad, you know, there's been some discussion that we need to look ahead, a little bit ahead, that, you know, it's not just in the context of this specific instantiation of GDPR. We have to think about the longer societal implications of collecting data. So what do we really care about in terms of explanation? So I should say that, you know, as far as in my view, there is no system out there that completely implements explanations the way social scientists and cognitive scientists understand it. They think that explanations, at least in terms of between human beings, basically is in 3 dimensions. The first thing is that it's contrastive, right? When somebody asks you something, you're explaining why this happened and not that, right? The second thing is it's very selective, right? You're not going to start off by saying at what time you brushed your teeth, you know, what sort of clothes you chose. It's very selected. It's very directed about what you're asking. And ultimately, explanations is a social construct. The reason we really care about explanations is because we want to learn about each other. We want to understand, you know, what sort of people we made. What that means in practice, of course, is that you have to understand a bit about where this person is coming from before you just give out an explanation, right? You have to understand the assumptions they're making and the level of expertise they might have as a customer, right? What is often sold as explanation in the literature is what is called as causal attribution or correlation. So typically you're saying, look, the reason the credit card was denied for you is because you're 35 and you are still unemployed. It's not a polite decision, right? It's hurtful to get a decision of that form, but that's the kind of explanation that that's being sold at the stage. So not that I want to go into detail, but I just want to point out that in the literature of machine learning, there are many different techniques. They offer different amounts of, explainability as you want it. I can come back to this. Yeah.
Just when you change slides, you say change slides.
Oh, sorry. Yeah.
Just you tell them which slide you're on.
There are numbers on this, but there's one slide.
First of all, let's ask if Daz has received the slide.
Yeah. Have you guys received the slides? Oh,
the question is if we received the slides.
Yeah.
How were they transmitted?
By email at the beginning of the session.
Oh, okay. I'll dig them out and I'll make sure that they're available in the room. I'm sorry, I'm like 200 emails in debt today.
Okay.
So I hope you could still make sense of the things I said, and the slides were necessary cues to make sense of it.
Okay, maybe maybe it's more interesting for you to see actually.
Yeah, great idea.
We're gonna switch the view to the screen where we are projecting the slides. So
yeah.
That was the single best video production choice of the day.
Good. Okay. So where I was at is basically saying the landscape of machine learning models and AI fits into this kind of spectrum where you have some models that are super accurate but not very good in terms of potentially providing some kind of readability, and there are some models which are not that accurate but are very readable. I think again, my view, I think that in terms of explainability in machine learning and AI, they fall into two basic types of categories. So the first one is essentially trying to use these kinds of interpretable models, right? And the idea, of course, is that you don't have to construct any kind of post hoc explanation. Now, you have to keep in mind that even when they say inherently interpretable, what they really mean is that it's interpretable to an expert, right? So I'm thinking of interpreting to an engineer, to a computer scientist, and this is very different from being interpretable to a user, right? That still requires a lot of work. The second kind of approach is to say, look, guys, there's no way we can compete with these awesome and scalable methods. Let's try to see if we can come up with post hoc explanations, okay? I'll just give you some illustrations. Again, this is not something that you have to implement in a system that you might be building. This is just to give you an idea of the kinds of things that are out there, just to have some concrete points. Going back actually to the history of AI, one of the classic things that people try to learn are what is called as decision trees. What it tries to do is, imagine you have a data set that basically says, what are the conditions that you play in, right? So if it's, for instance, if it's raining, you're not going to play. So what one of these systems tries to do is that it looks at this data and tries to construct one of these trees. And so the numbers that you see next to certain things like play and don't play basically says the number of points for which this is true. Okay, so there are out of 14 points, 9 of those points say that these are the conditions you play in, and 5 you don't play, and so on and so forth. And it keeps sort of making it more and more granular. Okay. Again, this is a very old technique. I'm just trying to give you an illustration. So the type 2 thing, where you try to do a post hoc explanation. So I'm changing slides, by the way. They can see that. The type 2 thing, what it does is that you have this fairly complex model. Okay. So what it's done is that it looked at a bunch of data points and sort of built this fine-looking structure that basically tells the right things and the wrong things, so the yes or no label. And you're asking about a very specific point there, this big plus sign. And what it tries to do is it tries to construct an explanation that at least explains the class of data points around this thing. Okay. So again, the benefit here is that it's local, because it could be that points that are very far away don't really influence the current concern that you have. Another example of type 2 thing, I guess the echo is coming back, but anyway. Another example of type 2 thing is some work that a colleague of mine has been doing. What he tries to do is he looks at the various ways these deep learning systems play, games like Atari and Go, and he tries to construct what is called as a program from the learned model, right? So it's saying, you took a decision to move if such and such factor had. And what you have to notice is that these programs are highly granular, right? You cannot make sense of it by looking at this. It says things like you move if the ball's position is 0.0086, right? It makes, you know, it's not readable from a very high level point of view, but the hope is that if you do learn a program at this very low level view, maybe you can cluster things and build, you know, high level view as you go along. There are sort of hybrid approaches that we've been looking at, and what this tries to do is to say, look, why don't we do two things at the same time? Why don't we focus on, you know, these kinds of interpretable models, and why don't we also construct, you know, intuitive explanations from these things? So a kind of work that we've been looking at, we looked at some of the you know, we looked at essentially science problems, right? You know, one of the things we do as children, as we're learning about science and math and so on, we take a number of these tests like GRE and SAT. So what we try to do is we try to understand what are the reasons we come up with answers for these things. So we take some of these questions and we construct a kind of representation which we think is similar to how we imagine it. So for instance, you know, it says Mike has a bag of marbles with 4 white, 8 blue, and 6 marbles, right? So essentially, and he pulls one marble from the bag and it's red. So what you can see is that you have this abstract representation that there's a bag of things. You take the first thing out and it happens to be, you know, red, and the rest is all the things that are left out of it, right? So it tries to construct a representation the way we actually try to solve the problem and gives you an explanation how to do it. Our hope is that maybe this can be lifted more generally to, you know, to a point where somebody who's not an expert in machine learning can basically just say, this is my problem spec, and it tries to generate a kind of representation that says, what's going on, why do you get this answer, and what should you be doing? I'm hoping that this can lead to some transparent AI, right? So that's all I had for today. So to sort of conclude, I think explanations are super important, and not just for legal reasons, right? And as I said, I think if you think about the societal impacts, about making decisions for people's lives, we have to be super careful about what these decisions are based on. My own bias here is that if possible, we should prioritize, you know, these more interpretable models. There's some argument, you know, among people in the community that, look, if you have a model that's 99% accurate, why do you care about interpretability, right? So that's a good argument, but if you think back about the panda example, and you think back that there's this 1% chance that somebody inducing a little bit of noise takes the decision way off, then maybe you'll think back about, you know, prioritizing the 99%. I think, you know, if you, you know, from the perspective of potentially building applications, starting companies and so on, and providing explanations to users, I'm not saying we can implement exactly what the social scientists ask for, right? But I think these 3 features are interesting to think about how you could provide proxies for these features. For instance, can I provide an explanation to the customer that's contrastive? It clearly says that, you know, why this happened and that did not happen. Can I be, you know, can I help him in his cognitive overload and give very selected, you know, explanations? And perhaps he can ask for more granular explanations as he goes along, right? And finally, what, you know, an explanation is not just one atomic thing. It's very context dependent. You need to sort of understand what is the user asking, and so what kind of explanation is appropriate, you know, given the context in which he's asking. That's it. Thank you.
Applause from MIT.
Thanks.
Yeah, yeah.
Standardizing around what states there are. Like I know consent types can be quite up a lot.
Yeah.
Okay. Sorry, they're answering a question. We are going to switch to another speaker here. Just a second. I'm putting the slides up. So GDPR ODI. Yes. Okay. No, why? Do you have the slides projected at your end, or do you want to keep this format?
Oh, it would be great if you could keep pointing the camera toward the slides, and if it's possible to, I don't know, pull it back slightly or angle it so we could see the whole slide. Oh, that's nice. That's nice.
Perfect.
Oh, that's perfect.
Okay, great. So let's move on now to the second speaker. So we have Ruben Beans, who is a postdoctoral researcher in computer science at the University of Oxford, currently funded by an EPSRC project, Petra's Internet of Things Research Hub, project Respectful Things in Private Spaces. So I'm sure there's many issues, like Ruben has authored a number of papers in last year even on fairness, accountability, machine learning. So I'm excited about what he has to say here. Thanks, Ruben.
Cool, thank you. I'm really glad that I was able to follow Vishek's excellent talk, because there are many overlaps between what I'm going to talk about here. So it will help me to skip through the slides that I did, because there are too many slides, but many of them are very similar to the slides. One of them is exactly the same, so that'll be fun. I'm going to be talking about some research that we've done over the last year with colleagues at Oxford. We've heard a little bit already about this right to explanation. I'm not going to go into too much detail, but it's worth kind of pointing out that it's actually quite an old right. It exists in sort of 1978 data protection legislation in France, and it was also to some extent in the 95 data protection directive. Then we've got it now, this so-called right to explanation in the GDPR. As you may have heard, there's like controversy about whether the right to explanation exists and what it consists in. Pre-GDPR, there was a lot of, before it was passed, when it was in the drafting stages, there was work by Maria Hildebrand, which was talking about this as a new era for the transparency of profiling. What my colleague Lillian Edwards and Michael Veal wrote more recently was that, well, whether it exists or not and what form it exists in, do we want it and why would we want it? So that's kind of what this research set out to explore. So we wanted to know, well, how should these provisions in the GDPR be interpreted? What kinds of explanations might be available from the cutting edge of research in this area? And what kinds of people might want them and why? And will they be happy if they get them? So I'm going to try and whiz through these, because a lot of this has already been covered in the previous talk. But there's a sort of general principle in intelligent systems research that we should build systems that can account for how they operate, to help users understand how their tasks are being accomplished. And when people built rule-based systems, so these are systems that are based on explicitly coded knowledge bases and inference sets, it was much easier to generate explanations for outputs, because you could kind of go into the rule set and extract the rules that were used in that particular decision. But machine learning is a little bit different. And so by machine learning here, I'm talking about essentially ways of automatically identifying patterns in data. And in particular, I'm mostly talking about supervised machine learning, where you've got labeled data. So this is data from a domain about behavior of people, for instance, where different instances in the training data are labeled with the categories that you're trying to predict or classify. And so you get the data, you train it on a learning algorithm, that produces a model, and then that model can be used to predict or classify things by showing it new instances that it hasn't seen before, and then it generates a classification or a prediction for you. And on some level, on a really basic level, machine learning is not really that different to fitting a line across a set of data points. And when you've got really simple models like this one, it might actually, a graph like this might give you the explanation that you want, right? So this just says, the higher your salary, the better your credit score will be. And that's the kind of explanation that you might want. You might be wondering, well, if that's all machine learning is, then why can't we just use things like this? So one reason we can't do that is that there might be more complicated relationships. There might be lines that aren't straight, lines that go up and down. In the case of C, it's not a straightforward explanation that you can draw out of that, because it depends on where you are on the gradient. Right? Another reason is that usually we're not dealing with the relationship between one variable and another, but we're dealing with multiple variables at once. So this is just using, this is just three-dimensional, but in many cases it's going to be multi-dimensional data. So as we saw in the last talk, one way that you can explain machine learning models is, in some cases, the model itself is a decision tree, right? So you can trace, if you want to know what was the explanation for a particular output, you just find the leaf node in the tree that was the output, and you trace the thinking all the way to the top, or you can do it in a reverse order. And that, in a sense, is a form of explanation, right? But often these decision trees are very complicated, and they're really only one class of machine learning model. There are many other kinds that are more complicated than that. So one form of, this is I can't remember the terminology that Vaishek used, but this is kind of like this kind of maps onto some of the terminology. Maybe, yeah. Potentially. Yeah. So this is a way of looking at all of the possible inputs and outputs, and then generalizing about their relationships in the model. But then there are also local explanations which try to explain a specific portion of the model. So you might look at, well, okay, if we have an individual whose salary is 30K and age is 30, what can we say about how the model treats that particular input and the relationship between the input and the output and nearby input spaces? So, the people who are between 30 and 35, or between 25 and 35, say, and whose salary is similar to this person. What are the features that contribute to the negative or positive classifications in that portion of the model? So you may be familiar with this slide. So yeah, this is an example from a paper called about a system called LAW.MIT, which is Local Interpretable Model Agnostic Explanations. And so yeah, I think Vaishek explained that pretty well in the previous slide. So, but this is an example of what LAW.MIT can do. So the image on the left is Google's Inception image classifier. And this is using LAW.MIT to explain how the classifier comes up with its classifications. And it classifies this image on the left, as Labrador, electric guitar, acoustic guitar. And with LAW.MIT, what you do is you perturb the inputs to see how that affects what the classification is. So you systematically blur out portions of the image, and these are called, I think they're called superpixels or hyperpixels. Basically, a way of dividing the space of the image up into sections, and you systematically blur out those sections, and you see how that affects the classification. And you do that across all the different inputs, and then for the portions that affected the classification of electric guitar, that's D, are those portions of the image. And then for D, you can see the portions of the image which made the classifier think it was a Labrador. So these can give us useful things like, for instance, this is part of a study where we did a broad overview of many different types of explanations. So I'm just going to go through some of them here. So what we call the sensitivity score is essentially a way of saying, well, if you perturb inputs into the model, what changes would you have to make in order to change the outcome class? So in this case, if someone didn't get the credit score that they wanted, that they needed to get their loan, we'd say, well, what other things would you have to change in order to get the positive result that you wanted? And this is actually implemented in some credit score services that exist. And this is I think this is one from the US. So you can say, well, if I got a new credit card, if I made a transfer balance, if I closed my old card, you can see the effect on your credit score by changing that. Another kind of explanation which we found from the recommender systems literature called case-based explanation. So what this does is it says, if you want to explain why a particular input got the output that it did, you find an instance from the training data on which the model is based that's most similar to that input, that got the same output. So, for instance, if Marion is like Vivian and Vivian paid her loan back, that would be one explanation as to why the model thinks that Marion will pay her loan back. Another kind of explanation would be, well, what are the characteristics, the demographics of people who got the same outcome as me? Or what are the characteristics of people who got a different outcome? And then finally, there's some new interesting work coming out that's looking at mostly at explaining image classifiers that are based on neural nets. And what they do here is they isolate specific neural pathways in the. This is a representation of an image classifier, and it looks at which neurons are firing when the image classifies certain elements in the why the model classifies certain images as it does. And what they found is that it looks like there are kind of particular pathways which activate things that look a little bit like floppy ears, things that look a little bit like pointy ears, snouts, and so on. So there's kind of ways when you're looking with, especially with image recognition, you can kind of draw out some sense from what's going on in the black box. But what these things don't tell you is about causality. So they don't tell you how things in the real world, why is it that certain attributes of a loan applicant make them more or less good as a credit risk? And what they don't tell you also necessarily is what it is that's caused the output in the model. So equipped with this kind of overview of some of the explanation styles, or explanation systems that have been proposed, we wanted to think about who might want explanations and why, and in particular in the context of the GDPR. So we decided to focus on the decision subject. This is someone who's had a decision made about them that has a significant or legal effect on them, and that was made using purely automated processing, and the kind of things they might want to do. So they might want to understand it in order to decide whether they want to mount a legal challenge, ask for a human to review it, or change the inputs that they've given to the model, for instance. So it's no longer forthcoming work. It's work that's been done and published. We did a series of controlled experiments to test people's perceptions of justice in response to different hypothetical cases. And we did several different studies. Some were in person, long, in detail studies where people came into our lab. And we did a series of online studies that, based on the in-person studies that were quicker and had more people involved. We wanted to test people's perceptions of justice in response to different hypothetical cases. And for that, we relied on work that's done in organizational psychology, which is mostly in response to human decisions. So usually decisions about hiring, firing, promotion, disciplinary procedures, and so on. And this is a kind of a large body of work that's been going on for several decades. And that breaks down perceptions of justice into different aspects. So informational, procedural, and distributive justice. Informational is, the information that was provided when the decision was made. Procedural was the process that was used to come to the decision a fair one. And distributive is about whether the distribution of outcomes across the population was fair overall. So we presented people with different hypothetical contexts. So imagine Sarah has been evaluated at work by a computer system, and that was used to decide whether she got a promotion or not. We looked at employment, insurance, travel, fraud, and financial loans. And we gave people the same context and the same outcomes, but different explanation styles that were drawn from those different explanation systems I mentioned earlier. And these were kind of standardized as much as we could. And we used these 4 different explanation styles. So case-based, sensitivity, input, influence, which was a measure of the importance of different features in the classification, and then demographics. So what other people who got the same decision, what were their demographics like? And so in the in-depth lab study, we got people to talk through their responses as they were considering each case. So we got a lot of rich qualitative data from that. So one person, or many people, but this is one example, talked about whether they felt it was okay for statistical inferences to be used at all in these kinds of contexts. So she said, she's been a victim of this computer system that has to generalize based on like somebody else. What it should be looking for is ability to pay back the loan, not characteristics of others who couldn't pay back the loan. In particular, people seem to really object to these case-based explanations. So this is the style where the explanation for the output goes and finds the instance in the training data that's most similar to the person in question. And people seem to really dislike this. So just because Joel performed badly in the end doesn't mean that Jing will perform badly, because there could have been other influencing factors. So maybe Jing is, despite having many similar workplace behaviors to Joel, maybe she's actually an excellent salesperson. She should get the job. In response to the sensitivity explanation, so this is where you imagine counterfactual situations where you had different features or different inputs. Some people thought this was actually quite a good way of proceeding, because especially in a case where you're trying to apply for a financial loan, the counterfactual explanation tell you the specific things you could do to try and change whether you got the loan or not. So in this case, the person said, well, if he's not earning enough money for the company to feel they can give him a loan of £5,000, that's fair. They're also giving an alternative. If they had an extra £2,000 income, you'd be successful. Or if you asked to borrow less, then you would have been successful. So this is the right thing to do. Reject him, but give him alternatives. And then people reflected on whether they thought these things were overall fair. This is mostly talking about the distributive justice aspect of it. So one person said, well, fair hasn't really come into it because it's a cold decision. It's not fair at all, but it is understandable from the perspective of the business. One of my favorite quotes from the study was someone who said, well, you know, after thinking about what it meant to be fair in an algorithmic decision-making context, he said, well, maybe what's fair is to just be completely chaotic and award the promotions or the loans completely at random. Chaos is fair. So those were some of the qualitative responses we got. For the online studies, we had enough participants that we could get statistically significant outcomes from the study. So one of our questions was, do these different explanation styles affect people's justice perceptions in response to these explanations? And we found that yes and no. So we did two different experimental designs. One was a between subjects design. So that means we split people into different groups, and we gave each group one explanation style in different contexts. And then we compared their responses across groups. That's between subjects. So each participant in the between subjects design got the same explanation style over and over again in different contexts. We also did a within subjects design. So that's where one participant in the study got different explanation styles in different contexts. And in one case, that was in a sequential way. In another case, it was in a comparative way. So they could see several different explanations side by side for a single decision. And we found that in between subjects, there were few statistically significant differences between explanation styles. And we think that what happened there is that people basically became habituated to the explanation styles. 2 minutes. Okay, cool. Whereas within the within subjects design, people were able to compare explanations side by side, and that caused them to think differently about the decisions. So yeah, people are unsure about how to attribute responsibility when there's an algorithmic decision. The role of explanations in influencing people's perceptions of justice is complicated, even when it's contextualized in a specific way. And the explanations seem to make the most difference to justice perceptions when people could directly compare them for a single decision. So I was asked to kind of reflect on the extent to which these explanation services might be facilitated by intermediaries. So this is a term that Nicola has used in his work. So I think this could work in different ways in different contexts. So in a business to consumer context, you can imagine trade associations, consortia of companies working in different industries could combine to create standards around explanations. You might also see PIMS, personal information management services, who are kind of facilitating explanations. And given, you know, particularly, so the thing I just mentioned, which was that people tend to pay more attention to explanations when they're comparing different explanations side by side, that seems to lend itself quite well potentially to comparison services. So when you're applying for a loan and you're comparing multiple different providers, if you could compare explanations for why you would or wouldn't get the loan, or the terms that you get the loan on between providers, that could be quite useful. And then in the public sector or in the employment sector, I can imagine NGOs or trade unions playing a role in developing standards or developing explanation systems. So I end there. I think that's basically, yeah, focusing on other forms of explanation services that would be more oriented towards the decision makers who are using these systems. So, and then finally, there's an interesting project in Germany, which is using subject access rights to try and reverse engineer the credit scoring algorithm that's used by the main credit rating agency in Germany. So that's an interesting example there. I'll leave that there. Okay, cool.
All right. Thanks very much, Ruben. That was very enlightening. So again, unless there are very burning questions, since we are running out of time here, let's move to the next presentation, GDPR transparency.
Which is also the last, I think, presentation.
Yes, correct.
Okay.
So Paolo Mise is a reader in large-scale information system in the School of Computing at the University of Newcastle. And he has a lot of expertise in metadata management and provenance, as well in system design and architecture. Yeah, so I'll leave it to you, Paolo.
Thank you. So
So the bad news is it's past 6 p.m. here, and everyone is really at the limit, I think. The good news is this is the last talk. The other piece of good news is that basically the previous two talks basically cover half of my presentation. Fantastic. It will be very short. Excellent. So that's coordination for you. That is a good sign. I think we interpreted this call in a way that is kind of consistent. But I won't go into much detail about then what is meant by algorithmic transparency and explanations from the point of view of the model. But we have seen two perspectives where you're trying to open the black box, which is the model that makes the predictions, either locally or globally, and another perspective where we basically use the model as a black box and we challenge it by providing input that is carefully crafted, i.e. some perturbation of the input to see what happens and try to get the model to reveal something about itself. The two very clever approaches. What I would like to talk about is the third idea, because I'm not a machine learning person natively. Everyone today is, but not natively. So I'm more of a data management person, and I like metadata. Okay, so let me very quickly, as a background, still use this to set the scope. Okay, we are interested in decisions that actually make a difference to people, and that people have really no control over. So, for example, all the world of recommender systems is out of scope because you're free to follow the recommendation or not. In all these cases that are here, basically decisions are made on your behalf, either by the machine or more commonly by some human who trusts the prediction made by a machine. It can be an intermediary that tries to explain, or it can be someone who pretends to understand what the machine does. But these have consequences, and these are the ones that people care about, as we have seen. Okay? This is the classic case. Now it's been like a textbook case. Just to go over, a few. Does anybody not know what this is about? Compass? Yeah. So should I say something about this? Yay! Thank you. All right. So this is one of the systems that is used to predict recidivism, which is basically the likelihood that you reoccur as a criminal. And a criticism was made to the system in public, so that through public on a web page or on a blog, to say, oh look, black defendants who did not recidivate over a 2-year period were nearly twice as likely to be misclassified as higher risk compared to their white counterparts, which obviously touches a nerve everywhere in the world, especially in the US. And the counter of that is also true. White defendants who actually did reoffend within the next 2 years were mistakenly labeled as low risk. So that clearly raises a flag of saying, what is this Compass system doing? Is there a way to plug in before we die? Is this working? Yes, thank you. Okay. So to which, and now I apologize because there was a reference to the paper that makes the counter argument, but somehow it disappeared. Fundamentally, the idea of the counter argument was, well, there's nothing really wrong with the Compass system. The problem is that the data is biased in such a way that the model is reflecting the bias in the data. That's basically the story. So when they get it right, Compass gets it right in a fair way. When it gets wrong decisions, then it makes mistakes. You can read it, make mistakes in a very different way. It misclassifies the white and the black defendants in different ways. In other words, the false positive rate and the false negative rate are very different. So that's that just to give a motivation of why one would be interested in actually looking at the data in addition to looking at what the model does. Okay, so models. Okay, this is the part that has been covered very well by the previous speakers. There are opaque models and interpretable models, and generally there's a trade-off. You remember? I think you had the chart, right? So complexity and accuracy. So opaque models tend to be black boxes, deep neural networks. So decision trees were mentioned as interpretable models, which are in this class. I didn't put them there. if you normally, what you would do, you don't use a decision tree, you use an ensemble of decision trees, for example, a random forest, and voila, you basically made your life very difficult because all of a sudden you can't really see what's going on. Lime has been mentioned, and I have the canonical taking a picture from Lime. Fantastic. And so here's the reference. There's also work that I recently discovered, but it's KDD 15 by Caruana et al. From Microsoft research on generalized additive models with pairwise interactions. People look at middle ground where the model is not linear because that's too simple, but it's not completely arbitrary. So there's still some hope that you can extract explanation out of it. Okay, so I'm going to skip this. This is the point that the Baino paper makes, the Lime paper makes, to say, look, don't really trust the accuracy, because as we already saw, first of all, there can be adversarial action that basically confuses the prediction. But even when things are done without any malicious intent, you can the model can get it completely wrong because it is again classified as a very high accuracy. But you know, these decisions are both correct. It's basically trying to predict whether a blog post is about atheism or a religious blog post. But the way they come to the conclusion is practically different. If you look at the terms that were used to inform that particular prediction are, you know, kind of significant in this case and completely random in this case. Okay, so at this point, if you have this kind of post-hoc explanation, then you start doubting that the model actually is trustworthy. Okay, so Lime, this is the picture of Lime again. Lime has two ambitions. One is to be model agnostic. It basically looks for, you know, locally linear neighborhoods of your target data point. So that's why you try to explain, you know, why you got a bad score on your insurance application and the local fidelity. So, okay, we've seen this. Now, what I want to talk about really is the part of the picture that is less looked after. Okay, so most of the ML community really works here, and what I'm suggesting is that all that happens up to this point, so before you actually feed data to the model, is equally important, because, for example, data bias comes from here, and key decisions are made during data collection and data preparation. Okay? So how you collect the data, and Thomas, I think, earlier from the MIT mentioned provenance. This is basically where this is going. Okay? So the more you know, that the contention is that the more you know about what has happened in this phase, the better off you are in explaining what the model will do, in addition to what we have seen. It is not a way to you know, snob or throw away everybody else's efforts. But I insist that this is not looked after well enough, and there's research to be done. And basically, you want to answer these questions. Can we explain these decisions, and are these explanations actually useful? So we haven't done any user study. Ruben has done a fantastic study on trying to understand what people actually expect. So we haven't done any of this, and we try to start doing, you know, can we explain the decisions and what does it take? Okay. So what this says actually is, to what extent does metadata analysis on the data help explain, for example, model bias? Okay. So there's two things. There's the provenance of the data, and actually the data itself, which is used to train a predictive model. So, for example, if you look at data profiling, there's lots of literature on data profiling from my community, essentially. But you know, you still do very simple things. It's like, okay, basic quality measures. Okay, that's really not enough. And when you look at what kind of data validation is performed before drawing the conclusion from the analysis, you see that in reality there's very little. Okay, so I have two kind of random examples from Taggle that I picked up today actually. One is, both are interesting. The data analysis of gun violence in the US, and basically, if you follow this link and see the excellent documentation about this, there's absolutely no profiling. So basically, I trust the data for what it is, and I draw conclusions from it. Okay? I don't question the origins of the data. The second example, global terrorist attacks, also, pretty heavyweight. And again, all they do is try to detect null values and maybe eliminate things that are, data that is incomplete. Okay, so there is a lot more that can be done, and the list of things that you can look out for is pretty long. So there's, when you collect the data and you do data wrangling, which is basically the dirty art of getting data in the right shape, possibly for multiple sources, integrated in a proper way. Joining different sources and so on, to all the pipelines that pre-processes the data and massages in a way that is then ready to be fed into a model train and decided as a big set of features. Okay, so the big data before gets to that point is massaged in very many ways, and here are some of the things that actually normally people do. The bad news is that lots can be done. And if you do it wrong, you get a model that you cannot trust. The good news, in my view, is that much of this can actually be documented. And if you bother to track what happens here, i.e. to collect the provenance of this big data set here as much as you can, then you are in a good situation, because you can try and reason about why the data looks in a certain way. And why did you remove outliers? How did you do it? Did you do it at all? What kind of thresholds did you use? What kind of techniques and so on? What kind of filters? Okay? And the good news, again, this is actually much easier to explain than the model, because what happens here is actually typically written to scripts. It can be your Python script, typically. It can be your TensorFlow script in Python. Spark, whatever, you can have workflows. NIME is a nice workflow management system that is completely transparent. So there's actually a lot of transparency here that is not in the model. And one claim that at that point is a bit too late to understand what's going on, because many of the decisions are made here, but you can actually go back to that. Yes. Yeah, no, I'm done. So if you have never seen a provenance graph, this is what it looked like. I had the privilege of working with the provenance working group at the W3C, and thanks to MIT for hosting us for 2 years, 2011, 2013. We ended up producing actually graphs, which means that you can actually then collect provenance, represent it in a way that is formal, and then query and analyze it. And you have a very nice metadata platform where you can hope to start answering these kind of questions. How far this is going to go in terms of providing explanations that complement what the machine learning people are doing is yet to be, I guess, decided. We haven't published anything, so please don't give it away. Joking. Lots of references if you want to keep the slides around, and these are my coordinates. Right, thank you. So this is actually late.
Right on time.
Okay. Yeah.
You're a perfect candidate for our community group. I hope you're going to register.
I think
Perfect.
you don't want to hear that, but I think that's not my lesson the first time.
Is Thomas still there? Yes. Okay. So now, basically, it's impossible to manage everything because we had 10 minutes for questions from MIT, and in theory we have 2 minutes until the end of the program. But we will keep it a bit longer going. Oh yeah.
Okay, we're going to have to jump off here.
Yeah, they jump off. Yeah.
Speakers and other things happening.
Can I ask a question?
Yeah. Yeah. Go ahead with your question. Yeah.
Unless somebody knows any clue of the answer. So if, can I speak?
Yeah.
So if I find out that you're 6 feet tall, and my algorithm decided that all 6 feet tall people are liars, so more likely to be a liar, am I obligated to release it to you that my algorithm decided that you are a liar?
Yes, to you, I guess. So to whom in particular are you asking?
It's an open question.
Well, it has an answer. I don't care. I just want the answer.
I think I don't care.
GDPR,
Yeah, I don't. Yeah.
the GDPR would oblige transparency. Sorry. The GDPR would oblige transparency. So, I mean, there would be several processes, but as an individual, you have the right to ask, and get the explanation. And if you're not satisfied, or even if you're satisfied, you could still report it to the regulator at national level, and they could do an investigation, and they have the right to look at the details, at the algorithm. So IP, for example, intellectual property is not a bar for looking at the algorithm.
Did you hear that?
Sort of, kind of. Did anybody else understood it better?
Yes, I did. Yeah, I got it.
The answer was yes.
Okay.
Yes, yes.
Okay, great.
That might depend on the height of the regulator. Yeah.
Okay, good stuff. And I guess I'll take a whack at it in the room here, which would be the way the question was asked. I think that number one, under Article 15, you'd have a right to know that there was personal data about you, and the personal data was something along the lines of, you know, user 123 or Jane Doe is likely to be a liar. You know, at least that data. So we have personal data, and then there seems to be this. We're trying to find it here, but it's like Article 13 or wherever you have the right to get some more information about the logic of the algorithms that are used that impact your rights. I guess there'd be a second question there, which is the result of this algorithm impacting your right in some way? So I guess that might be a trigger question there. But I think it's a good question because, you know, posing hypotheticals is one way to let all of us start to grapple with the meaning of this new regulation and how it's going to play out and what we can do to, you know, start to engineer systems to support and reflect this legal regime. So, hey, I want to thank everybody in the room that, Mark is coming up. I just want to thank you all for making this available and for Thomas to be able to present and for us to be able to get the benefit of your panelists in the room there. I think we should chalk this up as another successful collaboration with Mark Lazar and the consent receipt and affiliated communities. So thanks all.
Yeah, thanks, Dad. Yeah, thanks to you.
Really looking forward to seeing this stuff happen at MIT with Open GDPR. I mean, it's a really good effort out there, and I'm really excited to see that stuff happen. Thanks, guys, for the whole thing.
Much appreciated.
Does anybody have any questions for Thomas or the guys? No, we're good. We're gonna drink beer now. So.
Okay, great. So we'll lift the glass together, kind of asynchronously. Okay. Yeah. Thanks all.
Thanks,
bye now.
Thanks, guys.
I wanted to have a discussion.
Yeah, I know.
Could you guys mute? Do you mind muting the room in London? Thanks.
I mean, I do need to leave in 10 minutes.
Ben Hoxie.
Hello.
Hey, can you hear us okay?
Yeah, I can hear you.
Great. Oh, there you are. Hello.
How's everyone doing? That was an interesting talk.
Yes. Yeah, we're learning about the algorithms. You know, so one of the things when you're done with your talk, when we have some discussion, I want to maybe explore if we wanted to hack on your API a little bit and your open source code, could we maybe look at adding another capability for that in some way addresses the rights people have with respect to the
logic, learning about the logic of algorithms that resulted in some decision that impacted their legal rights. So I see you've got the a subject access request, the Article 15 stuff. You've got erasure request, and you've got some other stuff. Maybe we could talk about what would it look like if we hacked and tried to add something for algorithmic decision making, and then maybe if it worked, okay, we could make a pull request and your team could review it.
Sure. Yeah, let's talk through it.
Okay, great. So without further ado, Ben Hoxie has very kindly agreed to join us from New York City, United States of America.
All right.
And he is the project manager at mParticle, and it seems just from reviewing the GitHub repo, a frequenter of and kind of like aficionado of OpenGDPR, which is currently my favorite open source tool with respect to supporting and reflecting GDPR in code that works in a way that I think makes a lot of sense, it being API driven. So with that, thanks for joining us, and we'd love to learn more about OpenGDPR and hear some of your perspectives.
Yeah, thank you. First of all, thanks for having me. Appreciate it, and I appreciate the interest in the project. I don't have slides, so feel free to interrupt me at any time. Otherwise, I'm going to give you a quick rundown, and then we can chat.
Great.
So let me give you a little bit of context. So about what mParticle is and why we're doing this, other than altruism. So mParticle is a customer data platform, and if you're not up on the latest in the marketing stack, that means that we work with clients who are GDPR controllers to automate data collection on data subjects, to standardize it, and then to distribute that data to other processors. So basically, our entire business is personal data, and it is customer data. So we have aside from my personal interest in making sure that GDPR works correctly, we have a professional interest in making sure that the challenges of our clients with regards to compliance are smoothly met. Also, our business is really about integrating data marketing stack. So, it makes sense for us to help out here in terms of making it easier for them, if we're going to help them distribute the data, to help them be compliant with regards to the data. So that's sort of the context. We founded OpenGDPR a few months ago with a couple of our sort of best-in-breed marketing partners of AppsFlyer, Amplitude, and Braze, and we've been working with them to evolve the sort of the concept and the spec and the repo. And let me try to sort of break apart what the scope was and what we intended, and then we can talk a little about where it's going. When talking to our clients, the controllers, it seems that the topics of most concern were lawful processing, which there's been a lot of conversation around consent, legitimate interest, and the other four lawful processing umbrellas, and the rights of the data subject under, I think it's Chapter 3, around access, portability, erasure, rectification, suspension. There's a bunch of others. And so, we looked at both of these, and so we built a product in our platform for consent, and there's an IAB consent framework from the ad tech world, and I think Google launched a consent framework. So consent is both very complicated and also kind of addressed. Evolving. I should say it's evolving, and it's getting lots of attention. But we noticed that the rights of the data subject really didn't have anybody putting a stake in the ground publicly to say, this is how it should happen. And instead what we saw was a lot of processors saying, if you need to fulfill an erasure request, use this new API. Send a delete request to some bespoke API in our platform and pass us these two IDs that you have to collect, and good luck. And so in the same way that our core business is really about collecting and centralizing and standardizing regular customer events, it made sense to try to standardize this piece, just to say, this is what a request is, and this is how they flow, and this is how controllers can implement it both internally and to connect to their processors. So this was sort of the idea, was to lay out standard is the wrong word, to lay out a spec, a common spec for people to articulate and interoperate around their requests. So that's sort of the vision. Where we landed was basically a description of objects and of a mostly RESTful API that describes in a workflow and a defined status. Sorry, the list grows, so I think the list stops there. That defines how controllers can represent the requests, distribute them, receive the status, and then it's up to them really to aggregate and to respond to the data subject. I think the distinction, one of the challenges in the whole thing was really the distinction in the responsibilities between the controller and the processor. So, you know, I could walk through the spec. That's probably super boring. Maybe I'll talk a little bit about what's covered in it right now and where we're thinking it's going. Today, it only covers data subject requests for access, portability, and erasure. And even within that, it's a little bit funky because erasure is relatively clear to everyone, I think. You know, of the folks that I've talked to, the distinction between an access and a portability request is not crystal clear. And in terms of what are the processor's obligations in each. You know, I think for portability, it's relatively clear in that, you know, you have to extract the data. But for access, the question is, you know, how much of the processor's input does the controller need to respond correctly to a data subject about what's been saved and how they process it. I will also fess up right away that the other rights are not explicitly addressed. So the right of suspension of processing, of rectification, I think there's one or two others, they aren't covered. And partially that's because it was not obvious how that would be accomplished by API, but maybe that's an interesting topic for in 2 minutes.
Could you repeat again the major elements of the scope of the regulation that are not covered?
Yeah, so we set out to address the sort of loudest data subject rights of access, portability, and erasure. There are other rights in the spec, and you know, the spec doesn't say these aren't important. Sorry, the regulation doesn't say these aren't important. So the right of rectification, the right of suspension of processing, I think there's one around the right to object. These are not explicitly covered right now in Open GDPR, and you know, I think are reasonably good topics to think about what would it take to add them, what would that look like. You know, when people ask me about those, I usually say, well, the right to rectification is pretty easy. You're the controller, send in some new data, and you're good. But you know, we've added a lot of maturity around the other rights, so maybe it behooves us not to do that for these. I think the one final piece that I'll mention before I'm happy to chat is, you know, Open GDPR does not define what each processor must do. It's really a framework to encapsulate the request and to track the status rather than interpreting the regulation, because that's impossible within the context and the architecture and the business of each processor. So it's really still up to each processor to say, when I get this kind of a request, you know, I'm going to have my defined fulfillment process, and according to my architecture, my business, and the data, I'm going to execute it in X way. And of course, to communicate that in whatever legalese and DPAs and you know, communication as required to their controllers.
Perfect. So in the scope is my personal favorite article. Thank you. Article 15, access to our data. And then also the deletion or so-called erasure in their language in GDPR, English translation, and the right to object. And then not covered are rectify or, basically correct errors, restrict processing to request a restriction in processing. And then I would maybe add to that one, as I was mentioning earlier, perhaps also some way we could cognize the rights people have with respect to algorithmic decision-making and being able to gain, well, there's a kind of a mini access request here. Tell me about, what was it, the logic, or could you repeat what you found in there? It's like the logic of the algorithm. Yeah. And what was the section again? So it's coming up.
Yeah, I remember that section. It's about profiling, right? So automatic decision-making and profiling that results in sensitive, either user-sensitive data or results in impactful decisions. You're allowed to see what the result was or how that decision was reached. I think with the intention of like, you didn't give me a loan. You have to prove to me why and what data you used, that kind of stuff.
Yeah, what data you use. So to me, it seems like there's three aspects. Number one, like what was the input data? Oh, well, wow, your input data was incorrect. That doesn't relate to me, or it's old, or whatever. Or the number two is the, could you repeat it again? It's the model or the algorithm.
It says, if you sort of combine a few pointers together, it seems like Articles 13 and 15 say, a decision based solely on automated processing that produces legal effects or similarly significantly affects the subject. When an individual is subject to such a decision, the GDPR creates rights for meaningful information about the logic involved in that decision.
That's it. So the second thing is meaningful information about the logic, or let's just call that. The second thing is information about what was the algorithm that you used, or what was the model like. Walk me through how the function worked, as Sam said. Yeah. And then number three would be the result, obviously. So the result is, Sam is a good credit risk, because, Sally is likely going to be in the gazebo at 5 p.m.
Well,
yeah.
I would say if you take it sort of one step further, it's not always a black and white answer that these algorithms process. It's from various data points that you make. The system is effectively making certain assumptions, and then based on those assumptions, it's then evaluating a yes or no answer. So depending upon how granular, without violating intellectual property as much as possible, the only time you want to have that happen is if you're being audited by a government entity. How granular can you get into getting not only the data that's being used, but also the assumptions that come before the evaluation?
Yeah, what's interesting is, it just reminded me that there's a piece that it says in the portability definition, we are not obligated to extract inferred or calculated data. So they say that on the portability side, you only have to give them data about that person, about the data subject, and you don't have to do inferred or calculated stuff, but you are allowed to ask, as you've all just mentioned, about the process for decision making. And so my guess is that you're likely to get the result of the decision, the data subject's raw data on the portability side, and then on the automatic processing question, you're likely to get a very broad overview of what does it do.
What were the assumptions that were made with that data?
Yeah.
That resulted in whatever the end.
I'm going to guess that. I would guess that most people aren't going to give you, the ML bias tree or the, you're not going to be that detailed. It's going to be very high level. I suspect it would be nice if they did, but a lot of the expensive rockstar ML people are going to be out of a job if that's the truth.
I would think that would be a good starting point to abstract the logic from, though. Because then you can, based on the UML, you can determine, what does actually need to be protected in terms of intellectual property, trade secrets, etc. And you can start to abstract, it doesn't need to be reflective directly of the UML architecture, but it could be an analog to that as far as the logic that's being produced.
Yeah, I suspect that they're going to summarize the model in something like, this model takes X third-party data set that's, economic data. It combines your X personal information that we've already shown you, and it results a probability score for a purchase or a probability score for a defaulting on a loan or something like that. And then they'll probably stop there, is my guess. And then it's up to the data subject to say, well, their input was wrong because I did a portability request, and now I got to exercise my right to rectification to say that's not right.
Is there a standardization that you've developed around the portability?
No. So, because I'm grouping access and portability together because it's my belief, of course, we'll see how the market begins to respond to these requests in 2 days. But it's my belief that the access request really is a summary report about what was saved. And so a controller may need to ask the processors, what kind of data do you have for this person? Because they might not know. But a portability request is really just to dump a full extract of everything that was reported about the person. Again, not inferred or calculated. For our own implementation, it's public, so I'm happy to tell you about it. It's just a JSON extract zipped up. I think there's like a 1 line per day or 1 file per day or something zipped up. And then it's the controller's job to aggregate that across processors and deliver something reasonable to the data subject.
So it looks like it's section, we're just scrolling through it now, 6.3 in the specification has the discovery response, 6. Let's see,
so in the status object,
data format?
It's in the status object and the spec. There's a results URL, and we don't actually define in the spec what the format has to be. So once again, this spec really is very limited in scope in that it defines the statuses, the life cycle, and the communication, but it does not define how the processor fulfills it. And so we go as far as telling people how to communicate the status and what the result, where the result, to find the result, but not the format of the result. Find the,
Got it. Something I might want to suggest you take a look at is RDF and semantic web standards, because that might present a data format that is not only malleable to your own processes, but is at least some form of a portable standard, because the definitions of the data that you are considering as fact are included within the structure of the data itself. And so effectively you now have a portability where someone can take that data, and even though they might not have the exact same data fields or the exact same semantics, they can use the ontology structure of the RDF store of the semantic data storage to translate into whatever format that they might make use of, therefore being able to have consistency of not only export but import of what is portable data.
Yeah, that's a huge point. You know, the spec just says that it has to export it in a machine-readable format. And, you know, I think there's a bit of skepticism, I'll say for myself, around beyond the data subject being enlightened to browse what was stored, which I think is, you know, a primary concern and largely addressed with the access request. But skepticism for myself around, is anybody going to accept somebody else's data export? Like if I go to Facebook and I say, export what I have, is Friendster going to say, give us your Facebook export and we'll be off to the races? I mean, that's a pretty intense re-platforming of the data to understand what each column means. And even that's a monstrous thing.
We should probably get through some of the core items that we wanted to talk about. So I think you kind of segued pretty well from Sam's previous observation into the identity and authentication question that we have. So how if we were fixing to implement if we were implementing Open GDPR and maybe trying to test it out a little bit, and what's the idea or what's the vision for how data controller or processor that's receiving the request would authenticate the identity of the requester to ensure that they're complying with responding to the requester, but that they're not now violating the law by revealing the data to other third parties that are maybe posing as them.
Yeah, this is another huge point. So my answer is unfortunately going to be a bit of a cop-out in that it is the controller's job to communicate with the data subjects and to validate their identity and to make sure that they're not leaking or erasing data for the wrong person. And so for logged in experiences, this is relatively easy in that they can require that they submit the request while they're logged in, and then they have X security around identification and authorization of the person. If you are a publisher or most of your data subjects interact with you anonymously, it's super hard.
Yep.
And depending on the risk of the data that you collect and process is going to define the measures for which you go to make sure that person is who they say they are. So, you know, if all you're giving them is web cookies, maybe asking them for the cookie and then maybe that's enough. Maybe you don't care because it's so low risk. If it's super high risk, again, there is a nice trade-off here that most high risk things you're logged in or you're already authenticated. But if it's high risk, you know, you may need to ask the data subject to sign an affidavit or to in some other way prove their identity before you communicate with them sensitive data. But again, this is out of scope because this is up to the controller in their communications with the data subject.
Understood. And then the second question at a high level was, what's the current status of the project, And what do you have a sense of a roadmap or what you would like to do next by way of developing the project further?
Yeah, totally. It's a good question. So right now it's in the, what you see on the GitHub is the state of it, in that there isn't reference code. I would love to have a Swagger doc. I'd love to have reference code. I'd love to have sample implementations that people could just grab and stand up. We have implemented it ourselves, and it's our API standard for handling data subject requests. We've also gotten a lot of interest from partners and a handful have reached out and said, hey, we implemented this, we're working on this, or they've asked questions. But because it's open, I'm going to be honest that I may not know everybody who's implemented it, and that's the beauty of it. But we're working with, again, those three founding members really to try to put a stake in the ground rather, keep our feet on our legs, to say this is what we're going to use, and to try to swing some of the controllers. And I think once we can get a few controllers and a few processors on board, it'll become commonplace. In terms of roadmap, to be honest, it's the 24th today, so I'm happy that we reached a V1 and that it's live and that we're using it and that the world hasn't fallen apart yet, which is always good. I would be interested in covering the other data subject types if we decide that they fit the model. To be honest, I've tried not to think too much about them and get this stuff out the door. But if they fit the model, that would be super interesting. We always wanted to do something around consent. Again, it's called Open GDPR. It's not called Open Data Subject Access Request. So I would be totally open to making another repo or another project within the repo to address consent or to address another big chunk of it if we thought we could get adoption or support or interest.
Okay. You have another comment here.
Just a quick thing. So you said you don't have any necessarily reference implementations. You wouldn't happen to have an example of like a JSON data dump of the portability aspect that we could potentially tinker with?
So the JSON data dump is going to be extremely dependent on the processor's data structures, in that what kind of data they have and how they format it. Once again, it doesn't say it has to be in X standard format. Other than the JSON, right? But JSON is super open. And because every company, every processor is going to have their own data stores, some are going to be keyed on one thing, some are going to be keyed on another, they're going to have their own objects, and so depending on the way they extract and sort of prepare the result, it's going to be totally processor dependent. So I could give you, you could request one of mParticle, or I think there's probably a sample on the doc somewhere. It's not going to be very helpful though.
Could you give us a sample of one from Particles, so at least we can take a look at that?
I think so. Let me see if there's one on our public doc site. Happy to reference you to it.
Okay, that would be great. So any other questions or comments in the room?
I had a general comment that is at a bit of a higher level. I'm thinking as the world moves towards cloud environments and 100% SaaS environments, right, which is largely what you see in the different startup worlds, how does that impact GDPR, right, where your data is stored in multiple CRMs, multiple repositories, and I imagine it complicates the ability to kind of aggregate everything on a per individual request. Like, how are you thinking about that?
Yeah, that's a great question. So like your point is 100% right. And the business of mParticle is in collecting and then distributing data subject data. So without question, there's lots of cloud companies, but there's also, I think, the average marketing environment uses like 75 processors. And so the customer data is going everywhere. And mParticle's business is to help them do that. And so this is why we're helping them to be compliant as well, because it's a huge challenge. The pure legal answer would be it's up to the controller to merge the results and to prepare a response to the data subject. I'll be honest, I don't know how people are planning to do it. There is a difference in the work for an erasure request. You don't have to respond with anything. You can say, great, we did it. We've executed the erasure request as of this timestamp and confederate it out. You don't really need a response. For access and portability, you really only need to know one copy of what you've collected. You don't need to know every copy, because you don't need to get 10 versions of the same login event or the same e-commerce purchase event. So in some way, it's if you have everything that was saved. If you're spraying everything and you have no centralization, then you have a huge challenge. If you have some centralization, you can extract it from conceivably one place and you don't have to do tons of format aggregations.
Right.
But you're right, it's super hard. If you're spraying it all over and you don't have one place, you may be sending out differently formatted files. I don't know that there's another answer for that.
Yeah. Okay.
So it sounds like at a high level, that I guess if you could say like the stack layer that OpenGDPR operates on at this point, I might call like the envelope or the wrapper, and it's not so much like the payload to get to what Sam was saying.
100%.
Okay, which is fine. That makes a lot of sense. It's maybe hopefully so. Perhaps looking forward, one thing that we could focus on here, if we were to build out the code base, might be not to go deeper into any one, but maybe to just complete coverage. So like, get something on consent, get something on algorithmic decision making, kind of getting the subject access to that, and perhaps there's one or two more things in there, notices maybe or something, and then start doing deeper dives once there's full coverage.
Yeah, I think that would be super cool. I think your idea of using that data format of, I think it was RDF, that defines the schema, or you could use JSON schema or something that gives a little more structure to the raw export would also be super cool. These things make it a little harder to implement for the processors, but if it's more valuable, I'm into discussing it.
Yeah. Okay. So let's see. Any other questions or comments in the room here? No. Okay. Hearing none. So I'm not sure where the next speaker is, but you're welcome to, actually, like I should say, if you ever come up to Boston, please reach out. Cool. We're happy to meet up, and if I'm here anyway, to host you. And then I think I really do like the approach of your project, and I'm looking forward to trying to implement it. It sounds like Sam's interested in checking it out as well. It would be, I think it's one of the key missing pieces. And when we look at law at MIT, we were very much are interested in identifying ways. Fundamentally, MIT is an engineering school, and so we look at what would it be like if we could do a better job engineering legal processes. I think your tool is a good example of how to engineer the kind of functions and the flows and the technical capabilities that give life to the rules. So it's not like yet another amendment to a terms and conditions or privacy policy. It actually effectuates what the expectations are so that people can conduct these interactions and get the results in a measurable way. So I guess I just want to kind of say, I want to salute you and the team that came up with open source code. It's a really good start, and I do think it's worth spending time on and seeing if we can't, start to implement it and deploy and get more feedback loops going and to make it ever better.
Yeah, I appreciate it, and I appreciate the conversation. Thanks for having me.
Okay, it's a pleasure. Thanks, Ben.
Cheers.
Ciao.
Cheers. So I'm confused. If you don't release the copies of the data from other sources that have been passed to, then
we're going to go on mute
for
a moment for everyone out there in internet land while we get the next speaker online.
Hello. Oh, I can't hear, but I can see.
Thank you. Hey, Nick. Hi, welcome.
Thank you.
Yeah, so glad to have you. So this is so Nick is co-founder of Team. Hi, welcome.
Oh, thank you.
Oh, what's that in the background there?
Sorry, that was the YouTube live stream, which is how I was watching the talk before.
Oh, cool.
Now,
did you hear Ben, by the way, talking about open GDPR?
Yep, that was awesome.
Yeah, good stuff. Could you help us? Nick, do you want to just get us started with maybe do an introduction, and do you mind doing screen share to show us your slides and kind of advance them as you're ready?
Let me just pull that up. Yeah, so my name's Nick. Hey everyone, this is Jonathan here, my co-founder and CEO of Team Machine. Just let me pull up the slides real quick and we'll get going.
Awesome. So while you're doing that, part of the reason why we've invited Team Machine to present is because it seems like there's an opportunity in the spirit of engineering the law and maybe achieving more predictable legal results. To look at how data can be used within, say, an enterprise that is, among other things, trying to comply with GDPR to help basically structure the implementation and deployment of, for example, let's say GDPR compliance, like the kind of functions and flows we just looked at, in a way that's more measurable. So we can see things like, well, how are we doing? How well are we performing? Has this been successful? And then perhaps even regulators in the aggregate could look at this kind of data to see how is the law performing? Has the law achieved what we would consider success for what our expectations were?
That's really interesting.
Yeah, isn't that
where are they based out of?
San Francisco. Yep. So so with that, Nick and Team Machine, take it away.
Thank you. Yeah, that's a pretty good intro. And can I see the slides okay on my end?
Yes. It's a little small. But
can you go full screen? Present?
I probably can. Yeah, let me just. I think if I want to go full screen, I probably have to change it so that it is the whole window, not just the application window. So let's try.
Okay.
How's that? Can you see now?
Yeah, way better.
Okay, great. Cool. So yeah, so Daza, that was a great kind of intro here. Daza and I had a really wonderful conversation about the application of measurement along the process of the law. And that's kind of one of the examples we'll talk about at the end. It's probably the least tangible of the three examples I have. But we can kind of talk broadly about how the system works, and then more about each of those particular examples. And I will say too, I know it's difficult over screen share, but interrupt me please as the questions come along. Daza has done a great job of telling me when I'm not making any sense, and that's appreciated, well-received feedback. But thank you. So the three things I really want to go through today are the high-level vision of the way that we picture the future of organizations. Organizations being really companies today, nonprofits, governments, and then we think of kind of academia and individual disciplines as organizations too. We'll talk about tactically how our platform works, and then talk through a couple example use cases more so than case studies. One being user privacy, how users could share best practices around services that they're using, and make sure that they're increasingly improving their own digital identity and data privacy. And the second one, how companies can become more compliant with GDPR in a measurable way that could potentially be transparent to their users as well. And then that third example is the government iteration one. We'll get to that too. And I recognize that some of you may very well be familiar with the idea of collective intelligence, but just to really frame the macro level view of what Team Machine is thinking about, we think that this inevitable kind of coming future of organizations has a lot to do with the way that we make decisions as groups and the way that we leverage software to be able to do that in a way that optimizes for our organizational goals. So societal progress is kind of driven by the organizations that are formed throughout history. We're defining organization as a group of people who share some common goal. A lot of times in today's world, that common goal is profit in a specific market. We think that the definition of organization is much broader than that. And in organizations, what we're seeing is they leverage technology and they leverage people to increasingly optimize at their ability to achieve that goal. They scale up, they include more technology and processes to be able to achieve that goal across the scale of the organization, and they get better and better over time at achieving those goals. But that's what we call organizational learning, quote unquote. And as an aside, in case this piques anyone's ear and they want to ask about it, is we've also found that this correlates to the level of complexity that of a goal that an organization can handle is directly correlated to the level of complexity of that can be handled by the language that organization uses over time.
Wow. Could you extrapolate on that a little bit? You found the level of what is connected to the level of what and what?
Yeah, we're going to go down a rabbit hole here if we dig in too much on this one, but it's interesting on my end, so I'm happy to do that. Can you say that again?
We'll stop you if it gets too deep.
Okay, perfect. Thank you. The organizations through human history, as language has evolved, our ability to create organizations that have increasingly complex goals has evolved. You look at human history, like the way that the internet works, the way that communication has, let me take an aside here just to talk about the idea of language. Language in our definition is not just looking at the words used in English, but you can imagine like the differences between the particular vernacular used by a scientific discipline, the complexity of thought that can be conveyed through that level of communication, and the methods by which communication happens, such as the communication over the internet, enable much more complex goals to be held and achieved by organizations, is what I'm trying to say.
Okay, maybe we can return to that at the end.
Okay, cool. Yeah, that's interesting. Then I'm happy to talk more about that. And Jonathan has really defined this well for me and can even speak to it better than I can.
Okay, thanks, Jonathan.
So this all kind of gets to the macro level hypothesis that we'll inevitably use software to get better and better at optimization within organizations. In the next few decades, that's kind of like, where is the world today and where are we going? So then when we, to extrapolate on this learning thing, we think of learning as a function of three different components. The first one is experimenting, the second one is communicating, and the third one is decision making. And those kind of have a nice loop to them. Experimentation is, obviously within the scientific realm, it's pretty well defined. We think that can be applied to organizational learning, government learning as well. If you think about what are the outputs that we're achieving right now, what is something that we think might improve that, what's our baseline versus our expected outcome, let's run some experiment and then get some results and continuously learn over the course of that cycle. Government iterations are pretty slow, but the idea is that in order for an organization to learn, you have to be able to communicate the results of those experiments quickly and unambiguously. So what we've been saying is get the right information to the right people in the right context. And context is time. Context is the decision, the situation in which they're going to actually need to make a decision or use the information that they learned in a useful way. And this kind of addresses the idea of information overload too. Like organizations are saying, I have too much information, I have too much bureaucracy, I don't know where this information lives in our organization, I don't know who knows this thing. You can imagine in a perfect world, an organization of the future, those issues are handled by algorithms that give people the right information so that they can then make decisions. And then we define decision making as groups of people that are kind of dynamically selected to choose specific actions that make progress toward that shared goal. And the idea is that this loop is what is getting improved over time, and that's what learning is.
Okay. So the idea here is that there's the idea of just-in-time manufacturing or whatever, where you have the inputs come in just as you're making the car or whatever. So this is just like just-in-time information, so you can make optimal decisions.
That's awesome. Yes, that's exactly a great analogy for it, and I hadn't thought of that before, so I really appreciate that.
Okay, thank you.
Cool. So broadly, I kind of touched on this already. The application, we see experimentation happening and knowledge sharing happening in organizations today across the three kind of the triple helix. Companies move really quickly. They are experimenting often, but they don't have oftentimes don't have a lot of rigor to their experimentation. They're making decisions, maybe not categorizing them well or tracking them well. And then the bigger the organization gets, the harder it is to communicate clearly across the organization in context, like that just-in-time aspect. And there's decreasingly shared context because there's, first there's different teams, then there's different departments, then there's different units, then there's different entire companies. That just makes it difficult to communicate well. In the government side, I think some of the flaws are the experimentation that happens. Lawmakers come in and say, we think that this thing is important. Data privacy is important. We're going to implement GDPR. We're going to do the best possible job that we can to design it in such a way that it gets some specific outcome for the populace, and we hope that it works. But the accountability metrics on what were we trying to achieve with the legislation, and did we achieve that? As someone who's not an expert at legislation and involvement with government, it doesn't feel to me like that's something that's happening well. And then because of the slow experimentation cycle, and I think in addition to that, the incentives in government, communication is also slow. So there's this lack of transparency and accountability, which makes it hard for especially voters, the populace, to understand. And then science, I'd say experimentation is great. Communication is very difficult because of the uniqueness, the nuance of the language used in a specific discipline. So as human knowledge expands, the disciplines get more narrow and more deep, which means it's harder to communicate that information to people who are outside of those specific disciplines. They don't have the language, they don't have understanding the background information. So how would you characterize that in a way that was helpful to communicate?
Was that okay? That was a rhetorical question.
Yes, it's a question if we want to return to it.
Nope, back to you.
Cool, thank you. So second section here is broadly like what does Team Machine actually do? Knowing all this stuff about the future of what we would like to see in organizations. What we have is a protocol for representing knowledge and a recommendation engine for giving that knowledge in the just-in-time fashion. So the protocol for knowledge representation, really simply put, is time series data on what was happening when a specific decision was made, and then those actions that were taken are the actual decisions, and you want to measure the outcome. So you get something like here are all of here in the government example, here are the expectations of implementing some piece of legislation. Here are all the metrics that are specifically associated with that legislation that we're trying to improve. The implementation is that we're going to implement, we're going to take that legislation and enact it on a certain date, and then we can track over time how those metrics actually change. That can be applied to a government situation, that can be applied to a team situation. For example, we see, working with a company that wants to retain their employees, they can say, well, our employees take a survey once a week that assesses their happiness and fulfillment and engagement with the company. When those metrics get low enough, we have to take action to try to improve them. When we take certain actions in certain contexts, those work well. That this methodology can be applied broadly to a number of different contexts. Does that kind of make sense?
Yes.
Yeah.
Okay. Does anyone have any questions at this point?
Not right now.
No, we're good right now. I think we'd like to see more detail and then get into it with you.
Cool. Sounds good. So the other half of the explanation here is that in order to get the just-in-time information, we leverage that context that's built into the individual knowledge nuggets to understand what are the situation, what are the actions that have been taken in a situation that's similar to the one that I'm in right now, and which actions have been taken in the past that are actually that have an actual outcome that is similar to the outcome that I want to achieve. So you could look at the retention use case and say, okay, well, there's 500 teams in our organization. In each of those teams, we've had thousands of surveys taken for engagement. We've taken 350 actions to retain specific employees, and then today I want to go in and say, I'm managing an engineer named Joe, and Joe is disengaged. I can measure the context of my specific team against the context of all the teams that have existed in the past, and look at which specific actions worked for employees that look like Joe, and then have a confidence interval on taking a specific action that has been taken in the past in the organization to apply to Joe to have the highest likelihood of him continuing to be engaged, him not leaving the company. And that is really the communication aspect of the experimentation. The experiment is, each knowledge nugget is kind of its own experiment. They build on top of each other, and then the communication that happens is making sure that those knowledge nuggets can be presented in the right place, and the amalgamation of all of those knowledge nuggets can say, here's what we think is the right decision for you to make right now.
Okay.
Cool. So I don't know that it doesn't sound like I have enough time to really give a demo, because I think I'm already behind the schedule of this presentation, but the use cases that I think will make this more tangible and can really open up the conversation around GDPR are the three parties that are involved with the GDPR regulation. The first one is obviously the end users. Second one would be the companies who are providing services. You have controllers and processors, and then governments that are first off enacting GDPR, and then the follow-on governments that will enact regulation that's similar to GDPR. And for each of these, I think the interesting use cases to talk about, as Daza and I were talking about this, are for individuals. If you used a system like the one that Tin Machine had, you could have people who had a customized assessment for their data privacy, and said, okay, you're using these services, you want to achieve this level of data privacy, you want to achieve certain assessments, like your data is used in these ways, or you're only using services that are GDPR compliant to a certain degree. Then people can enter recommendations into the system that say, well, if you in a certain situation, if you wanted to make sure that you were only using services that that gave you clarity around rectification, as an example. One of the many end users who was using this service could then say, oh, I learned that Facebook doesn't do this. So if you want to be,
your audio is a little muffled.
Can you hear me now?
Yeah, better.
All right. What did you miss?
Just start from again from the beginning of that sentence. If you're something interaction with Facebook.
So yeah, so if someone had evaluated Facebook and said Facebook is not doing a good job of they're meeting the minimum requirements for GDPR, but they're not meeting the ideal requirements for GDPR around data privacy, and we're kind of co-creating those ideal requirements as a community. This is a type of system that would allow someone to say, hey, people who care about this higher threshold being met, don't use Facebook, or only use these aspects of Facebook, or make sure you set the setting in Facebook so that you get to the level of data privacy that's important to you as an individual.
Okay, so it could allow for some kind of benchmarking and rating against these metrics, so people could use it as a as one of the factors in deciding a service provider.
Right. Exactly.
Awesome.
That's that's really, and I can jump to this slide here. This is really going into that recommendation engine piece that was on the left side and saying, okay, in the situation that you're in, you're looking for what the data privacy, like what level of data privacy you have. Give me recommendations so I can move in the direction of achieving the metrics of data privacy that we've created as a benchmark as a community.
Okay.
So that's one. The second one is, I think the second one that's worth talking about here is for companies that are providing services, like how does a company transition from being not GDPR compliant to GDPR compliant across a number of metrics to minimally compliant to ideally compliant, like that same idea of co-creating, kind of benchmarking, not just what does the legislation say or what are people's interpretations of the legislation, but also like what is the community of the internet's co-created idea of what data privacy should include, and the opportunity to be transparent around those specific metrics that are used for those for that assessment. So you might say, the minimum is we need access, we need right to object, we need erasure. This company does that because it's required by law, and we can show that there's a specific assessment around the company's execution of those things. And then, okay, well, the community has decided that rectification, clarity around rectification is really important to us. So we can also see that companies are doing that. There's an assessment around those metrics. And right now, the way that this kind of looks in our flow, we can show you kind of an example from UX that we have for an actual customer is this first, I don't know if you can see my cursor, but the first column here is what does it look like from the user's perspective? The second column is what are the actions that the company is actually taking? So this could be, in this case, this would be the processor. And then the third column is an individualized assessment for a specific metric. So if you were saying access, it could be or erasure, it could be like the time to erasure, and we can create a standard around that. Really would require expertise from your guys' end to figure out what are the assessments that are associated with that.
Yep.
And the idea of doing all that is that now we can create best practices across entire industries or all SaaS companies or something like that to say, in that same flow of recommendations for individual people, we can say, here's what IBM implemented for their GDPR. Here's what Facebook, here's what Flickr, here's what Airbnb implemented for their GDPR. That's working in a way that is compliant to the ideal case. That's the standard that's benchmarked for the community. You can do that same type of thing, and here's how you might implement it. That's the power of the recommendation engine in this scenario.
Very awesome.
Cool. I know I want to be able to answer questions, but I just wanted to bring up this last point here. This is kind of like on the top piece, this is what a specific decision might look like. And on the bottom piece is what we call the computable evolutionary narrative. But really, that's what I referred to before as like the context for a decision. We're doing something, we're not just using, we're using a specific type of reinforcement learning called symbolic learning. And the reason that I want to bring this up is because as we use our own system and implement algorithms, the idea of understanding meaningful information about logic in the GDPR compliance, symbolic learning allows us to do that directly. We can see what were the specific elements that of past decisions that were used in the process of making this particular recommendation. And I think that methodology is generally really powerful. It's not usable in every scenario, but it could give a much deeper perspective into what logic is used to make recommendations for a variety of services, including Team Machine.
Dynamite.
Cool.
So we were just having a little bit of a quick, I don't know, like a tribal meeting here, and it's the view of all of us that we'd be very grateful to extend the time for the presentation if you'd be willing to share the demo so that we could get maybe a sense of
what it looks like in implementation, and then have a little bit of a conversation about what this could mean. We've got people around the table here that are, I'd say very classy engineers and deep expertise in certification and, kind of like enterprise, standards-based assessments, and we've got lawyers and candlestick makers and like a lot of it. So I'd like to kind of have a basis for dialogue, if possible, around your demo.
Yeah, that'd be awesome. So I'll show you kind of two important screens here. As soon as you log in, there's a high-level overview of, and this is kind of for an organization that's a client. It's a client. So they're a company that is, what do I want to get to? Here, they're a company that is implementing transformations, specifically around moving companies from the waterfall development methodology to agile development methodology. So you can think of this as closest related to the companies compliant, transforming to be compliant with GDPR use case.
Yep.
This case, there was a company that had an assessment specifically around all the different metrics that are relevant to being a healthy, agile team across hundreds of teams within an enterprise. And the way that this works is over the whole, we're able to see where the teams are. The green bar is the health goals that have already been achieved, and you're contextualizing the entire transformation of this organization by the end goal that you're trying to achieve. And when you get into the back end of this was basically a test harness for data that was fed into their system so that we could see it on our end. And it's not the prettiest thing, but it allowed me to explain it. You're measuring this. The leftmost column here is the full assessment of what are the different components of that we're measuring across the entire agile team. Where are those metrics today? And then this is the rightmost column here is like, where is the goal that we have for the entire team? You want to hear it all?
Just a quick question at this point is, what's an example of how a goal would be articulated in this context such that it was trackable and measurable?
Yeah, Jonathan's gonna help me out here because I think he has a better explanation of this than I do.
Yeah, so when the team takes an assessment like this, they look at, okay, what are the improvement areas we want to really move the needle on? And in this case, this team said, we want to increase our happiness index and our trust and respect. And so it takes their baseline index and it looks at what other teams in their situation have done, and it recommends recommended growth items, and that's what's on the second column over here. So it effectively is looking at other teams like them, what's worked for them in the past, but it's also incorporating expertise from consultants and coaches who have worked with a lot of teams like theirs and have just recommended, certain items. So we have a whole lot of different, recommendations. And then the team, towards the transparency that Nick was just talking about, they can see, well, why was this item recommended for us? What improved on these other teams that we're talking about right here? And this allows them to have open discussion during a team meeting. And you're talking about an environment with like 10 people in it. So they can decide, well, let's try this over the next 3 months, and let's try this over the next 3 months so we can achieve those growth goals. So it's really just adding, data, context, and, insight into the decisions they're already having to make as a team, and giving more grounding to the group decision that's being made.
So how do you measure a unit of happiness or respect?
Oh, these are qualitative surveys.
Okay.
Yeah. So each team member was, before they come to a 2-hour meeting, they've taken a survey. They've said how they felt about the team. Other stakeholders involved with the team are also surveyed. So everything is just relatively indexed on a Likert scale.
Got it. Okay, great. This is interesting. So in this demo, is this also used with, I don't know, maybe
not so much like survey-based data, but maybe more like operations data or logistics or something that measures, like a thing in time and space?
Yeah, absolutely. So the way we craft the assessments is that they can map to either qualitative inputs from surveys or from quantitative inputs from data sources. And a real concrete example of that in enterprises right now is DevOps teams. They, most of their metrics that matter are driven from more quantitative, data-driven metrics. The product engineering teams seem to be making a lot of improvements around more qualitative metrics because that's more the agile philosophy in this case. And then there's assessments that can combine both.
Awesome. Okay, and I'm sorry I couldn't hold the question. Is there more of the demo?
Yeah, absolutely. Do you want to walk through the rest of the columns here?
Well, I think that gets the gist of it, right? Yeah. And these other columns here, they just give insight. So like this column right here, where it says historical assessments, we're going back to the exact team and the exact improvement that team made so that you can drill down into the data. So, we are doing some statistical analysis, but it's all, mapped to a symbolic process. We can bring back the exact data points and the, exact teams like yours. This really helps to empathize with why a particular action might produce a particular result. Or, you can even call up this team and say, hey, when you guys did this 2 years ago, talk to me about what worked and what didn't work. Let me gain some better insight into it. And that's what we call this product and knowledge marketplace. It's really about, sharing knowledge in the context of the decision making.
That's enabling the Article 13 and 15 stuff around meaningful information about the logic. Like, it's not just meaningful information. It's not just parameters. It's we can walk you back step by step through each time this action was used and the specific outcomes that it had, and why we're pulling it as a recommendation for why you should use it in your current context.
Interesting. Okay. Is there more of the demo?
This is pretty much it. So the way that this piece of it was implemented and for the customer that I was talking about was they have a front end by way of by which their customers can take a survey that is then fed into our algorithms in the back end, and then we're spitting out their collection of recommended growth items from their clients and consultants and team members and their historical knowledge nuggets. This was really just a view for us to be able to ensure that we understood what was going on and to show it to other people. One of the things we're building right now is an implementation that can do this completely on its own without integrating into a separate product.
Better. Okay, pretty impressive. So I want to kick off with a couple of questions. One of them is, could you extrapolate a little bit on, well, first of all, thank you for sharing the demo and for talking us through your approach. I think it's really novel, and it definitely speaks to conversations around here in law.MIT.edu and in the Human Dynamics Lab about how the law itself could be more measurable and how we could look at, what sometimes almost feels like a quagmire of subjective and not well standardized activities and behaviors such as legal dimension of activity, and begin to look at ways that could compute and computational models that could help us to measure and improve and optimize legal activities. And then for me, the big success metrics would be, could we engineer systems such that we can achieve more predictable legal results all around. So thanks for sharing that. That's it's good stuff. I guess the question that I would like to have as facilitator's privilege to jump off first would be, could you extrapolate on the collective intelligence aspect of your approach? And again, it looks like there's there's definitely group
there's like groups and teams, and there's information that multiple people see. But I sense, or I think I remember that there was something even more, I don't know, transformative, almost transcendental about your collective intelligence approach. And I just appreciate if you could kind of spell that out a little more.
Yeah, absolutely. So the collective intelligence piece of it is just defined by the group of people who are using a specific instantiation of the software, or like a specific assessment to find the information that's relevant to them. So on the one hand, if you had a group of people, teams within an enterprise learning from each other on retention actions or something cool like that that drives ROI, wonderful, right? That's a cool shared intelligence within an enterprise context. Like, what if you think really broadly about this? What if you said, how can every government in the world learn from each other on the data privacy regulations that they're putting into place? Like, look at GDPR as an experiment, and look at GDPR within each country that it has to be implemented in as an experiment, and then say each of the specific aspects of the legislation of the regulation are pieces of that experiment. What did we learn from that? What were we trying to achieve by each of those? In the future, when the U.S. implements similar legislation, or when another country does, what will they learn from that? What metrics will they be trying to improve, and then what can they have learned from the other governments over their time of actually implementing this in a very tangible, quantified way, as opposed to just an intangible case study, like, oh, well, as we design legislation, we're going to have to look at what the EU did. I think that piece of it is a really important part of the collective intelligence. Systems like the individual data privacy recommendations, it's cool if we got everyone who is on this call and everyone who's at MIT who's focused on GDPR to contribute to a system by which we can all improve our data privacy. But what if there's 1 million people who are running those same experiments and contributing their own knowledge to the system that gets contextualized in when people need to implement things? What if it's 100 million people, right? That's where the system really scales up to be valuable.
That's exciting. Okay, so I guess I'll wrap the first thing on collective intelligence with saying, as you're saying, if we could imagine or hypothesize, how this could work. If there was thanks, Harry. If there was if you imagine that something like Open GDPR were scaled well, so that we could start looking across organizational boundaries and jurisdictional boundaries to see trends in compliance, like you were saying, and then maybe go the next level deeper. Hey, Bill, welcome. To see even things like, user feedback, or, get maybe more perspectives on the activities that are happening. And then maybe that could be a way that that could serve as one of the data inputs to systems like Team Machine that could provide an overlay to monitor and measure performance of I guess the law, you could say, but in compliance with the law. And then perhaps if the legislators got a little bit better at stating things like the goals of the law, the way they might in a nuclear test ban treaty, or in an environmental kind of regulation where they're looking to cap carbon at some overall level, and then maybe they have like a cap and trade and a tax incentive and some other stuff, but you always have this stated objective goal that you can measure the performance of the law against. Like you could say, well, did we achieve the carbon level? Was there a nuclear test that we detected with seismic, whatever, monitors or anything like that? And so if in GDPR there were these kind of like stated objective goals, then maybe we could then use platforms like yours to measure how close we got. And then finally, I think something that Sandy Pentland talks about a lot here in the Media Lab is, could we then actually go the next step and use that to optimize further what should the law be, like in view of the performance that we're seeing? Like, did we get the law right? Did we Are there other ways to achieve the goal better? Was that even the right goal? Now that we got it, did it scratch the itch? Like, did it achieve what we were really hoping at the end of the rainbow? And so we could maybe start having a better measurement of all that. So that's kind of what I got out of your answer.
Yeah, and I two things I would add to that. I think that's a great synopsis, and I appreciate that. Two things I would add would be the first one is there's some automation that actually comes with the, you know, like what should the law actually be? Like when we get increasingly confident in these systems and see these systems making recommendations that are right most of the time, we don't always have to go to when we have a certain level of confidence, certain confidence interval in the recommendation, we don't always need the human in the loop. There's a really important process to have it designed so that there's a human in the loop, but there's some decisions that will be so clear that the algorithm can, you know, algorithms can make recommendations on it that you don't need it anymore. And the second piece is that the assessments themselves can be iterated on by the people who are involved. So it's not just, okay, you know, the collective intelligence comes from recommendations on what is the growth item? What is the item by which you can increase your data privacy? What's something that I did that worked well for me context may also implement to achieve a similar outcome? It can also be, what are the assessment metrics that we use? How do we improve those assessment metrics over time? How do we improve entire assessments so that the context can be increasingly well-defined so that the communication, the just-in-time communication can happen in a way that is increasingly relevant and unambiguous.
Beautiful.
Would you be able to dive in a little bit deeper on the reporting capabilities in Team Machine? Like what sort of dashboards or reports I could create if I were in an organization and I wanted to discuss this with teams or my board?
How do you best to answer that?
Yeah, I mean, currently, I mean, in all honesty, we're doing a lot of these projects on a customized basis. But what seems to be a common thread is, you know, outlining the goal you want to make in the organization as a whole, and then tracking towards that goal with metrics that, you know, can really get buy-in from stakeholders that you're on the right track to achieve the long-term goal. So one of the, you know, one of the reporting requirements we hear a lot in the enterprise transformations is, you know, well, that's great that more teams are becoming agile and that we're moving faster, but what are the bottom line metrics? Is it delivery output? Is it defects in software? What are the bottom line metrics that, you know, meet the ROI goals that I have as a VP for the company? Yeah. And so, you know, it comes down to just building out business intelligence dashboards and prescriptive analytics that kind of meet those stakeholder needs. It's a little different in each case, but I think the overarching goal is to, you know, articulate the goal, show the progress, and show that each of these decisions that's being made is making things better and better towards what the company wants to be.
Absolutely. So I think more to the point, I was trying to figure out if these sorts of, you know, visualizations could be self-service, or if this was something, if I had your software, I would have to, you know, request from you all.
Yeah, our goal is to make them more self-service, you know, get the data in a format where you can, you know, send it over to Amazon Redshift, use the latest business intelligence tools, and, you know, we want our strength in our product to be around the group decision making.
Mm-hmm.
Any other kind of questions or insights? We were just talking about measuring. Were you following the thing, Bill? When
yes.
Okay, great. Yeah. We had a late entry. Okay, well, any questions for us? You know, you guys have taken a really admirable amount of time putting the presentation together and prepping for the session, and now going through it, you know, in the middle of a work day. So I'm very grateful. Can we get you back somehow? You know, so short of like I don't know, like me signing up MIT as your like anchor client, could we maybe give you some insight or I don't know, feedback, or is there anything that we could contribute?
I have something on my mind, but if you have anything,
go for it.
Yeah, I'd say you know, one of the things we're kind of playing in a new space. You know, advocating for collective intelligence, advocating for data-driven management. From an academic perspective, it's not very new, but from a business perspective, it is new. And if I already got, to the just-in-time information analogy is awesome. If you have other ideas of ways that we could say these concepts that I said more clearly, more concisely, the feedback directly that on things that I said that really didn't make sense, all of that would be really well received. Smart minds that have eyes on this and give feedback is extremely helpful to us. That's the thing that I would say. And if you don't feel comfortable in this setting, or if there's not enough time, then all that would also be really well received via email.
Any feedback?
I do have a question though.
We have another question actually first.
You may have covered it. I may have missed it. How much of what you're working on is strategically open sourced, and how much is like closed source?
Yeah, we've talked about this a little bit. We haven't open sourced anything yet, and the idea would be, I think, the core algorithms of what we're working on is probably not something that we want to open source, at least until we have some stake in the market that we can feel confident about, or some momentum that we can feel confident about. But leveraging this technology to achieve things that, as collectives or as groups, like let's create dynamic best practices for people on data privacy, particularly around GDPR, like the individuals example, is something that would be really cool to be able to reinforce with the algorithms that we have in a black box way. And we've talked about this in terms of building narratives around evolutionary biology, around scientific sharing for the context of academic papers. It's something that's interesting to us. It's just not something that we've worked on a lot yet.
Thanks.
So to piggyback on that question, what do you currently, or in the future, what other systems do you plan on integrating with? I know you mentioned maybe one, but I didn't catch it.
Yeah, I think the integrations, they happen at a couple of different levels. One is, how do we get data? And, our biggest challenge right now is getting data from companies in a way that's cost efficient and time efficient. So building integrations into the ERP systems that they use, into the communication systems that they use, and into the survey systems, that helps map into the assessment basis for the, the tool art itself. So.
I feel like a vampire right now.
Oh no.
Okay, sorry about that.
It'll be light. What was the very last thing that you said? I'm sorry, there was like a photonic disruption in the room.
Yeah, I was saying the integrations with ERP systems in companies, communication systems, so it's email, it's phone calls, it's meetings, and qualitative information such as surveys that can test things that are not necessarily qualitatively tested. So those are some of the integrations we have to input the data, and then integrations to output the data include business intelligence tools for dashboards. It includes interfaces that we can touch people through transactional emails, text messages, dashboards, and all the ways that are meaningfully So our philosophy as a product is obviously to be as focused and slim as possible, and then use these other great tools to create a great user experience.
Okay, great. So how do we follow along on you guys' progress and keep in touch with you?
Yeah, I think Nick will follow up with some information, and we're a growing startup, and we're trying to find like minds and build community, and it's one of the reasons we're really happy to have the opportunity today.
So I guess, and I'm going to help you out a little bit. Number one, teammachine.io.
Yeah.
Thank you, Daz.
Number two, if you want to relive the glory and the splendor of the slides, they are embedded in the event site now, as of moments before, like we went live. And number three, can I add? I don't know how email or what channel communications friendly, but when I do a follow up with the notes and everything from this event, could I include your contact information?
Absolutely. So this is I probably should have made a slide that said it much bigger than over here, but this is our contact information.
Oh, that way. Here we go. Nick. Yeah. And then they're it's fun to visit them. because they're in this very groovy like startup space in San Francisco.
Oh,
so there's just like every aspect of all of that is nothing but wonderful.
Very cool.
Yeah, if you're ever over here,
500 startups,
and we'll show you around the office, and I can make recommendations on other cool stuff and companies that might be relevant to you and things like that here too. So just open communication channel on my end.
Okay, so I guess we could I'm not sure if you guys are timing out in the meeting. I understand, and people here, we probably need to take a break shortly. But would people indulge one more like hypothetical while we have them on the line?
Absolutely.
Okay, is that okay with you guys in San Fran?
Yep.
Okay, so let's just go for like the brass ring is right ahead in front of us. So let's just like I'm just going to jump for it. Let's say that let us envision that you know, some amount of time from now, there's like a wide deployment of Team Machine, and there's a motivation for companies, for regulators, and for individuals in different ways to get the benefit of using it. Okay, what might some of the goals be, and how could some of those types of goals, how could appropriate goals be measured, and what sorts of data and sources of the data could fit? And just to get us started, like one thing I could imagine that to me seems like a natural would be, as you said, Nick, like if Article 15, request for data, we could just measure there's requests made, and in FOIA space, Freedom of Information Act, there's a number of open source platforms and some other portals where they make a lot, they get a lot of mileage out of looking, here's the date that the request for the public records was made, here's the date it was fulfilled or denied, or something like that. And that they get a lot of business value out of that, including estimating how long will it take to get a given public record. Oh, well, this one's kind of like that one. It's a piece of cake. It'll probably take 3 to 5 days. The other one, needs like, review by the Attorney General and, a congressional committee, we're guessing, 10 years or never. And so to me, it seems like one simple one might be Article 15 subject access requests. And then with a, although then articulate, and then I'll just go further and say, and perhaps a goal might be something like, of all the subject access requests that show up on the system, we get responses that are deemed successful or complete within 1 business week or something like that. So to me, like that might be like a very like almost toy rudimentary example of a way to do it. What I really, that's not a brass ring. I think that's like, I don't know, like a tin, I don't know, like lid on a can. I think the brass ring might be then if you had like policymakers that said our underlying goal for GDPR is something more systemic or kind of population wide, such as having personal data act as a new asset class. So like our goal is that people now have such ownership and control of the personal data that we are seeing a measurable bump in GDP of at least like 0.1% of GDP solely based upon exchanges of ownership rights where the individual is the owner for personal data, or we're seeing like like a competitive industry in some market is measured somehow for people that are now like racing to the top to have to be measured and performed well as providing best GDPR skills, and we're seeing that that's now a competition point within a market. So that those would be maybe examples of just over the horizon kinds of goals that we could imagine measuring, and then one that may be like available now. So how close did I get? Could you evaluate like my extrapolation of how a GDPR module or implementation of Team Machine could work?
Yeah, I one thing that oh, good. Can you hear me now?
Yep, you're good.
Okay, it's just be a little bit of a loop, and I'll try to ignore it. What you bring up about the personal data as an asset class is really interesting to me because I've been thinking about, for a long time, blockchain use cases around data ownership is like very interesting as a thought experiment. And one of the things that you could do, like not just, okay, well, let's analyze this particular use of the data within an assessment, but you could create a series of different assessments that apply for different contexts. So you could say, here's the minimum GDPR compliance requirements for a company, and then here's the transparent version that we show to all of our users. And then you could say, here's the ideal benchmark we were talking about earlier, like a co-created community internet, community of the internet nonprofit version of what we think GDPR compliance could be, or data privacy generally, even on top of GDPR could be. And then you could build another assessment that said, if you're someone who is trying to generate value from the ownership of your data, here are the additional requirements, or here are the different sets of metrics that you want to use within a separate assessment around how you can maintain data privacy and security, but specific to someone who is selling their personal data. Because there's a whole slew of different things that you now want to think about. It's like, how are these people using this data that I'm selling? How are we fairly evaluating the value of this data? And all of those things, that goes back to my idea of what I suggested earlier, is that like these community needs to co-create those assessments as well. Like those are what iteratively improves over time. Does that answer your question?
Yeah, I think so. I think you sort of validated that we're thinking about it broadly the right way. And then I like how you broke it down in a role-based or kind of vantage point-based way, saying like, it really is important that the success metrics and what we're measuring would and should be, different and adapt to the different clusters of users. Like the policymakers are measuring different things than individuals, measuring different things from companies, and then there's going to be other stakeholders in this personal data ecology too, doubtless, that will have their own views. So having this kind of folksonomy of assessment models to be able to emerge and support and reflect and adapt to the needs of their communities, I think makes a lot of sense.
One thing I wanted to add there is, in these having the different types of assessments, these are newer issues for society. These are complex things, and often, these type of debates get broken down to narratives that have two different points of view, and one of them's good and one of them's bad. And, with all the different points of view that need to be reconciled, you can take experts, and you can take consumers, and you can represent a very broad, fragmented points of view by taking these different assessments and relating them back to one another, so that it creates a more realistic picture for decision making. And I just think it's so important to break out of that duality of the narrative into something that really is a richer way to communicate about the problem as a whole.
Here. Beautiful. Okay, anything else in the room while we have guys? No? Okay, then just a round of applause for you guys. Thank you. Our hands together. Okay, thanks very much. And hey, I'll be out in the Bay Area, by the way, in the first few days of June. So I'll definitely look you guys up and maybe get some more of those snackies and 500 startups.
Cool. Great. Yeah, thank you so much for the time. This has been awesome. Again, feedback is very well received, even if it's a scathing email about how wrong we are. I'd love to hear that. So really appreciate it. Thanks all.
Okay, will do. I'll share your contact info. Thanks again, guys.
Take care.
Bye. And this is probably a good time to sign off the public broadcast now that we're done with this part of the program. So if you're out there in internet land, you can find all of the content for this discussion at GDPRhackday.org from law.MIT.edu. So thanks very much, everyone, and look forward to seeing you online. Bye-bye.